Welcome everyone to the 2025 OpenZFS User and Developer Summit. There are those in-house, those online. Welcome. If you're online, chat in the various chat platforms and get yourself noticed. We will do our best to incorporate you in the discussions. Being the Developer Summit that has sprouted into a User Summit, has always been a hackathon day for the second day of the developer portion. So please start thinking about your projects. And we have, per tradition, some remarkable Lego gifts. We will put up the projects, vote on them, and I will mail those to you if you so desire. And I'm thinking if someone looking at the stream or the Zoom remote participation, if you have a project that you're working on during this, I say it's a valid project. If show of hands, like, yeah, maybe we put that on the board, and if you're on planet Earth, I'll mail it to you. Space station's not so difficult, but we do have a cool space shuttle if you're in that field, and we'll work something out. Brian, I'm sure you've got some contacts we can work with to get that anywhere in the near field galaxy. So welcome, welcome, welcome. We're back in Portland. People were pretty happy. Thank you, Paul, my model here. This is your event, not mine. I want you to drive it, and I've updated the schedule based on feedback this morning. And perhaps now with these topics that have emerged, I know there's some people who are tied to each one and definitely want to be here. So what I've put up there is, after our little opening roundtable, the whole notion of OpenZFS 3.0 from an early, non-stressful, aspirational approach. We had a great discussion yesterday about long-term support cadences. I don't think anyone revealed one they love, but there are ones of record out there that drive operating system projects, be it the Linux kernel, be it OpenSSL, be it all these external factors that are often thrust upon us. So it's things like that that I think get incorporated at this early stage into the broad notion of the next major release of OpenZFS. We had a great discussion yesterday about the test suite and other strategies of quality. That does play somewhat into release engineering, but we were somewhat clear on what we definitely don't want to do and what we can aspire to do. Moving on from that, we had a great discussion last year about libZFS and channel programs, and someone put something on the board about collecting channel programs, perhaps in a common repo. Those are very related insofar as they are opportunities for the public to bring their code to leverage ZFS. If you're writing a snapshot manager, having a really solid libZFS core or otherwise is attractive, but it's been a bit of a bumpy road. Let's just revisit that topic and see what progress has been made since last year. So we don't have a name for it yet, but from the recent Basecamp and discussions last year and other things, there's a notion of a bucket or bouquet type data set that is an object store that is either full featured or very low level, and there was a great recent discussion on the production user call about what that might look like. So various folks have been thinking about that. I'm sure you each have an opinion. I know some of you have opinions, so let's just visit that and decide what we want to do and definitely don't want to do. And moving on, didn't make it on there. User space OpenZFS. It's come up several times recently. I'll punch it on the topic there, on the schedule there. And the limiting factor driving the schedule here is who's available. So if the first, let's say, two of these, the notion of OpenZFS 3.0 and test suite and quality things have the appropriate people in the room, great. If there's anyone who's concerned about the user space ZFS and need to leave, show of hands, and really want to have it front loaded so we get to it, you'll be here all day, Chris? Sweet. So I'll put this on my own list and I'll update the wiki. So user space. So if this loose schedule works, my apologies to those who are scheduling their entire day over YouTube around our schedule here. Sorry, that's the nature of the beast, that we have people coming and going, that we will accommodate those voices as best we can and be nimble and flexible. So thank you for your patience on that. For those who just rolled in, and my apologies to the stream, There are restrooms out to the left there. There's a brand new, literally brand new ADA restroom to the right. Lots of food. Give us your feedback on food. And there's upgraded Wi-Fi, because last year we had some issues. We have a much larger screen than last time. We are, as a community center, working to upgrade about everything we can. Actually, let's go there. At the Oregon Latvian Center, we are very pleased to have added some cushions, because last year, after 8 hours of intense discussions, people became a bit discomforted. I'm sure I'm forgetting something, but welcome. It has been inspiring and amazing to date. I thank you so much for your amazing work. There are vendors in the house, but they're like leaving that sword at the door, and I thank you for that. It's been very vendor neutral, very open, very respectful. Everyone here is subject to the OpenZFS Code of Conduct, which is a very reasonable document. I'll print one out and put it up if you haven't seen it, but it's one that other projects can aspire to follow. Any questions for me at this time? So, we will be starting with an intentionally...
Recording in progress.
No worries. Hello, Zoom lady. Let's see, we will start with an intentionally broad support roundtable. We have a very prominent support provider. We have a prominent consumer of, be it their services and others. And this starts with self-service support, also known as documentation, which everyone has their personal definition of how successfully we're doing with documentation. And so I will start gently with that and ease into what are those tiers looking like now, and what should they look like? Because in all of this, I want you to be dreamers and think about what the future we want looks like, okay? Thank you, everyone. We will transition to a few of us in front. It beats green? Yeah. Okay. Daniel and Alan, could you join us up front? And if someone else very much has some opinions here, join the discussion. It's your meeting, not mine. Whatever works. Oh, I like that. Very professional. Question? Don't want it. I'll just try to kick things off and let you run with it. Thanks. Yeah, of course. And are we vaguely on time? Possibly? That's awesome.
I don't know that it matters.
I know. Oh, that's pretty darn good. I will take notes, as I do on the production user calls. Not live and typo-y, but I'll do my best. So, I'll start with a story. Recently, someone on a forum using, I believe, pfSense, or was it OpenSense, had one of their mirrored boot drives fail. That happens, and OpenZFS accommodates that quite well, and the host OSs do reasonably well. And they went to find the documentation to remedy the situation. And I think they found the FreeBSD handbook page on ZFS, which was some of the best darn documentation when ZFS hit FreeBSD 7 or so. Was that 15 years? However many years ago. And they followed the docs, which explained, yeah, you want to use these. I think even the device naming was old school, and no notion of, okay, so we'll get your take on it, but this, and it's documented in the call there. But it was not the best advice available. But that's what the real world looks like, is if you have a problem, you just start searching, and you get what you get, and you probably will get upset. And so I believe we can do better, and I want to frame it from our self-serve resources like the wiki, which I've been trying to keep up to date for the calendar at this very event, but there are some very dark corners of it. There are companies on the companies list that are way out of date. There's the manual page documentation, which is quite good. It had that breakup during a Dev Summit a few years back, and we're getting there. But let's think about what that can better look like, and then work our way up to, oh, I think I have a major issue, I have a major project. What does that look like from a consumer perspective with a company like Daniels? And you can introduce yourselves when we get there. My name's Michael, hi. Don't worry about me. And Alan's company, which has done some very prominent and well-documented, yet some of it secret, work with companies of all sizes, and you can describe your services best, but the resources out there, and I'm very grateful you're doing that, but I think we still have room for improvement collectively as a community. And then there's, of course, there's a question of, well, is it OpenZFS documentation? Is it OpenZFS on Windows documentation, or Linux, or FreeBSD, or some of the more common platforms? Where are we at? Where do we want to be? So let's take that little seed and work from there.
All right, I'm Daniel Bell. I run a company called Bell Tower in New York City. I do sysadmin as service agreements and also fractional CTO work. Yeah, I've been using ZFS seriously in production since 2019, and yeah, I've had the same sort of encounters that Michael's talking about with you know, running into the Sun documentation, which doesn't necessarily have much to do with OpenZFS anymore, and you know, just figuring out the various forums, Reddit, the OpenZFS wiki, which probably needs a little bit of TLC, both on the design and the navigation and the how up to date it is, and so on. And then I solved most of my problems by hiring Clara and getting 5 years of backup. And running a lot of commands no-op until I figured out exactly how all the plumbing worked. But yeah, that's my experience so far.
So to introduce myself, I'm Alan Jude. I'm the head of solution architecture at Clara, and we do ZFS development and support subscriptions to basically help everybody, whether it's, you know, at our large research institution, we use ZFS and we need support for when something goes wrong, or even just, you know, we deploy ZFS as an MSP for customers, and, you know, our techs know ZFS, but when we hit one of those hairier problems that need next level expertise, we want someone to kind of fall back on to get the support we need to deploy what we need. And we also do what we call the design and implementation, which is a solution where we help you select the right hardware and deploy it and tune it and get it integrated into your environment and running your workload as performantly as possible. So applying all those ZFS best practices and making sure you have a disaster recovery scenario set up and all that type of stuff. And through that, we've seen, you know, all of the best and all of the worst configurations that you can imagine. And, you know, I've been looking at how we can make ZFS more supportable, what things and tools that we can bake into ZFS so that when someone does run into a problem, it's easier to debug it, or you know, if they do have what turns out to almost always be hardware-caused problems with ZFS, that we have the tools in place to be able to fix it, rather than, especially when you're working in someone's constrained environment, you know, where maybe it's health research data, and so there's all this HIPAA compliance stuff, so we can't just bring in our own tools and change the operating system, right? For compliance reasons, everything's locked down, and so if more of the tools are built into ZFS, then it makes it easier to support it in place. But at the same time, there's almost always an advantage to being able to bring in a newer version of ZDB than the one that's baked into the version of ZFS that broke. And so, you know, the fact that we can just bring in ZDB and compile it and use it against an older pool is still very helpful.
Have you worked in any compliance-oriented environments, Daniel?
Yeah, so I've dealt with a lot of, had to deal with a lot of compliance, auditing, segregation of information, and, you know, and so on, and obviously ZFS helps a lot with that, but only, of course, if you know what you're doing. So, and that can be a little bit tricky to find out. I think there's a lot of, I don't know if this is true in the wiki or the handbook or you know, the articles out there, but I do find that there's like a little bit of sort of a cargo cult mentality about how people set up and you know, do the initial setup, which counts for a lot with support. For example, if you label your disks in a useless way, then your recovery gets that much harder, especially when you're dealing with remote hands in a data center. So it would be nice to to get some sort of best practices more centralized, which might be difficult because I mean people obviously have different opinions about how everything works and how everything should be set up, and there's the feature releases are so I mean they feel rapid to me. I don't know if everybody would.
Once a year is relatively rapid, I suppose.
Well, it feels.
Then again, every time I've built a feature and then know that someone runs into the problem, it's like, well, we have this feature, but it's in the version that's not released yet. Wait another 8 months and then you can have it.
Right. I mean, I don't think I felt, and you could tell me if this is crazy, but I didn't feel 100% confident performing encrypted replications until fairly recently. Right. So so now I mean, I feel so confident that some of the concerns surrounding encrypted replication are solved. That my go-to recommendation, my default operations would take 100% advantage of encryption, where I might use secondary encryption last year. So I think that's a big part of the support challenge is not just finding the right support that makes sense, but it's the right support that makes sense for 2025 November.
Yeah, and kind of maybe to bring it back to Michael's points on documentation and so on, it can be very difficult to build the right documentation. So, what's in the FreeBSD handbook now has evolved a lot since I rewrote it in 2014 or whatever that was. But the difficulty there is, we provide the prototype of the command, right? It's like disk fails, you do zpool replace old disk, new disk. But we don't know whether the user has a SATA disk, a SAS disk, or an NVMe disk, and those are all going to have different device names. And even, or multipath or whatever. And even if we knew which one they had, there are other situations like, the number of the disk. And so the users that need the most help with that, who don't know the difference between the device name for a SATA disk versus a SAS disk, or might not know on the server they rented from a cloud provider what type of disk it has, or if it's VirtIO, then that's a completely different device name. And those users are the ones that would need the documentation to be more specific about which one to use, but they're also the users that don't know which one they have. And so, short of documenting 8 different ways and confusing them and leaving them guessing, how do you service the users that don't know which disk type they have to know that the example in the documentation needs to be modified slightly to work in their case, or what it would need to be modified to work in their case?
There could be tools to assist with some of this, though. I mean, the FreeBSD installer, for example, does a fairly good job of. No, you disagree?
It's a lot better than it used to be, but it is still ask you a lot of questions that, as a new user to ZFS, you probably don't know the answer to.
I will admit that I don't. Yeah, and I don't.
And my
use
biggest
it
problem
anymore,
is it is the type of thing where you learn a lot by watching someone who's never used it before use it.
Right.
But there's limits to what I can do to it now because I can do it with my eyes closed. I've been through it so many times. I can press the buttons before the menus pop up.
Right.
Right, what it sounds like is that we need a support wrapper that says, hey, you are running this type of stuff, to say, hey, this is how you pre-feed it from a user standpoint of, hey, I know I've got 60 bay drive running SATA drives. They're all the same. Okay, this is how to figure out which one's blinking.
If only it was
I know,
that easy.
Yeah, we were asked for
Ideals.
perfection.
Yeah.
Well, because I've seen a server where it's got 12 hot swap bays across the front, and you couldn't tell that 8 of them are on a SAS controller and the other 4 are on the motherboard's SATA controller. And so they won't all have the same device name or the same performance.
Or they actually have backside drives that, oh, I didn't realize there was one on the back.
Yep.
Yeah.
So I think this sort of also gets into another issue with documentation, that the best practices change over time, faster than the documentation changes.
Right.
Often.
So like when I was first setting up my big NFS servers in 2012, we had little SAS connected SSDs, well, little by modern standards, that we used for L2 ARC because, well, that was like the thing that people were saying that you should do. And then like shortly thereafter, it became clear that at least at that time, that was not really a good choice, that there wasn't enough main memory and the L2 ARC drives weren't actually all that fast on the SAS controller. And then we went for 8 years without building a system with L2 ARC in it. And then all of a sudden, I read a paper from 2019 or 2020, I guess it wasn't a paper, it was a presentation. But anyway, from, I don't know if it was from BSDCan or if it was from one of these or something, but and said, oh, actually L2 ARC works now, and you should probably use it and provision it, provision your systems with lots of memory and put lots of L2 ARC in them, and you'll actually be happy. And so it was only I don't know, maybe 2 years ago that I changed our standard configuration to do that. And I don't think there's any documentation anywhere that said, this is a recommended configuration. It was, you had to read presentations from vendors about these were the things that they tried.
It's pretty specific. If your memory's not maxed, you probably still don't want to do that.
Yeah.
So.
And it really depends on your workload, but even more than that, the working set of data that's hot. And if it all fits in RAM, you don't need an L2 ARC. If it's much, much larger than your RAM, then an L2 ARC is still not going to help. It's kind of, there's only this one sweet spot where it actually helps. And to your earlier point, if you have too much L2 ARC in relation to the amount of RAM, then you will spend most of your ARC as pointers to the L2 ARC and not actually caching the most important data in the fastest RAM. And so it's really difficult to document. It depends. Especially when, all the scenarios, you couldn't possibly cover them all. But yeah, it's difficult. It's a start,
Yeah.
yes. And you could provide some best practices, but you really have to put caveats so that people don't just blindly follow it and then end up with a system that's worse than if they just hadn't spent money on a bunch of SSDs.
I remember I sent a support email to Clara about optimizing performance for a database, and I basically took, I think I spliced some things out of the OpenZFS wiki at the time, and then a couple other sources, and I sent what my suggestions for tuning this thing was, and I just got a list of don't do that, please don't do that, that's crazy. It was, it's tricky to find. I mean, maybe some, I don't think any of it. I mean, I think a lot of it didn't really make sense ever. So, but again, a lot of these things are moving targets as well.
Say, if I could pull the conversation up just a little higher here. So one of the things we're seeing is on the TrueNAS side, we have the problem way worse. It's ZFS, it's NFS, it's iSCSI, it's all the other things, running apps, you name it. But the reality of where we are in 2025 is people don't read documentation. 99% of our users will not read documentation. I don't care how good it is.
Most people in this room don't have man on their computer.
Right? So the reality is we're seeing and we're pivoting our doc strategy towards generating a lot of good content that could be scraped by AIs, because that's where people are starting with their journey.
They ask a specific question and want just the answer to that.
Exactly.
They don't want to have to read a whole paragraph, let alone a bunch of pages.
I think that's where, as a project, we should be thinking about not where the hockey puck has been, but where it's going. Let's see if we can get ahead of something for the first time. A lot of times, we're always behind.
Well, and we did an article on this recently where we came up with some pretty common questions and fed them into a bunch of different competing AIs.
Yep.
And they came out with all kinds of ludicrous answers, including tunables that don't actually exist and never existed, or just recommendations, or like you could see where the AI made the assumption, and it's like that assumption makes sense that there would be a tunable to do that, except for
Because
that's
it's
not how
being
that works.
trained off of Reddit and all kinds
Exactly.
of suspect
Insisting
sources and all that, which I get. So
insisting OpenZFS has
Yeah.
features that only SunZFS had.
I think this
Yeah.
is where it becomes important for us to have an authoritative source of just all the raw information. It's hosted on the OpenZFS website, so AIs in the future, as they scrape, will give priority to this information looks more legit. On a date on everything.
I think a more inviting wiki would actually be a really huge improvement here because
Well, because the wiki was originally designed when the OpenZFS project was just a way to try to pull a bunch of developers together who were working on completely disparate systems. Now that we have one common repo, although we're still working on getting the Lumos people back on board, maybe it does make sense for that wiki to expand a bit, and it's not been maintained very well over the years, but that's understandable as well.
It seems to
Yeah,
me
I
that
have
one of the
experience-
most important
Yeah,
I know it's
is it working?
Yep, we can hear you.
Yeah, the one thing that I have experienced is like when I was like initially started and even now when I'm stuck by looking for some problem, it's difficult to find the solution. Like it's all scattered around in some forums or somewhere. So I don't know if they can do something to like centralize that, or like if you solved some problem with the ZFS, can put it somewhere that others can access more easily than the scattered forums here and there. So.
yeah, I guess I trained on IRC, Reddit, and then Practical ZFS. I mean, it was all over the place for sure.
Or at least have some, like, from the main OpenZFS page, if you have some links or something that we can navigate and go to.
Yeah, I will say that the man pages are actually really, really good. So whoever's doing those, I mean, bravo. That's the source of truth that I get the documentation and I check that and read what it does, and it's always very clearly spelled out in the man page. I know, shocking, but yeah, I mean, I will say that those are extremely reliable and usually up to date, or mostly up to date.
Well, and they benefit from the fact that the man page will match the version of ZFS you have, where any website is, short of doing what TrueNAS does of having a drop down of the versions to have different versions of the documentation, it's likely whatever documentation you found is not for exactly the version of ZFS you're using. And that, I don't know that there's a good solution to that. If we can't maintain one copy of the documentation up to date, we're not going to be able to maintain, every branch's version of the documentation either, right? So when you want to use the new feature, it's just undocumented?
So I have a terrible idea. For the hack day, we should absolutely put together a pile of docs and dump them into a couple different LLMs and just have them walk us through setting up a new system. Adding a new pool to an existing, VM or something, or having it give us recommendations on how to set up a new system, and just write down all of the ways that it is terrible and start figuring out how we want to communicate those things.
You probably want to scrape all the man pages together,
Right.
vectorize it
Yep.
into proper RAG-based.
Semantic search, yeah.
Yeah.
Yep. I mean, and that would be ideal, is having at least a semantic search for the read the docs stuff, and just get it so you can have slightly better. I mean, is anyone providing a not full LLM but just semantic search against your docs service?
We are today on the TrueNAS side.
Okay. Because that would be great, and doesn't require anyone to go with OpenAI or
I think
any
that-
particular AI
Yeah,
vendor.
I agree that I think the idea of sort of compiling all the unstructured data, at least to see where we are, and then that could be iterated, if there's problems with how it queries. That could actually be a useful way to use AI to at least figure out where the holes are, what people are asking, and how to, because I mean, it's a pattern matching machine, right? So it's going to figure out and we're gonna see where the problems are really fast, based on a corpus of documentation fed into some system like that. That could be helpful. It would be work to bootstrap, though.
Sure. So one of the things it can give us, though, is it can give us personas and use cases. I know that's boring product design stuff, but you know, some of the vendors in here probably have thoughts on what their personas and use cases are for their customers, and we probably want to pay attention to how the docs
as the production
affect
user
them.
up here. Yeah,
Right?
absolutely.
Yeah, exactly.
That's exactly what we want.
Well, and that's kind of the approach Clara took with its ZFS Basecamp, which is basically a documentation hub, but tailoring that documentation based on maybe somewhat on a persona, but also just like where the user is in their journey with ZFS. So the first category of stuff is all like, I've heard a little bit about ZFS, but I don't know what a VDEV is. And it kind of walks through, you know, these are the building blocks of ZFS and how all the pieces work. And then there's, all right, you've convinced me, I want to use ZFS. How do I make that first pool? How do I decide what record size to use for my database? All of those kind of things, and it's a whole series of documentation and videos and snippets and other bits that we put together. And then the same thing goes on to, you know, all right, I have ZFS, how do I keep it running? Or I want to do, how do I do my DR? And I kind of, you know, I'm an advanced user, I want to know all the real cool tricks that, you know, aren't for beginners and so on.
Plus Clara's specific use case and detailed articles about how do I do X, Y, Z. Are also
And you kind of
goals.
breaking those down into where they're going to hit the correct target audience. And, you know, not overwhelm the new user with, this is how you know, hyper optimize for your specific Postgres database, when they're like, I don't know what a VDEV is. And trying to break that down, but, you know, even there, as Chris pointed out, you know, only the more classically trained sysadmins of us are reading that kind of documentation. And so, you know, we've also pivoted to like having videos that explain it, and can we do, you know, YouTube shorts or whatever, and try to, you know, have a way to address those most common questions in a kind of bite-sized consumable way. But, you know, documentation is a hard problem.
Two questions, a few things. So one, what do we do about the very wrong docs and blog posts that are out there that we have no control over? Do we almost need a meta interface that intentionally says these URLs are wrong, and yes, they come up all the time, but in our docs are either masked out or we just warn, but if there's Oracle documentation that no longer applies to Oracle ZFS or OpenZFS, it's great for historic purposes, but that's a problem.
Sadly, we can't convince Google to stop surfacing that in search results.
Correct. That's why I literally said we should maybe have our own interface to it that's like
Yeah, Michael, it's
overlay.
really about authoritative. You know, who's authoritative? So if it's coming from the OpenZFS side and it's making the, hey, we are the authoritative voice for this documentation information, then your scrapers will hopefully prioritize.
Right.
That's what they're supposed to do if they're working. That's what we've had to do with TrueNAS, because there's a wealth of horrible information on Reddit and blog posts and things from 2017 that just will actually get you in really hot water if you follow some of that advice. And so we're having to work, right? We're having to work real hard to make sure we have authoritative information up there with all the gory details that we know going into it 99% of users will never read, but when they go ask the AI, they will probably get a better response as a result.
The problem with doing a whole list of what's bad is it's very likely that the various crawlers out there will see that and go, oh, there's more links to it. So people obviously want to surface it more.
Obviously, great.
Yes, and it's any sysadmin knows enumerating badness is a path to pain.
Okay.
Right? You can't just keep a list of all the IPs you want to block. You have to be, here's the list of good things.
In addition, you would be far ahead if you made a list of good sources of information.
Exactly.
And actually trained a large language model on that good information, then try and make a bad list or try and get rid of the bad information.
And a quick one.
Because, you know, you can't just block all of Reddit.
Oh, of course.
As much as we may like.
And so there's a Linux history here. We've got manual pages, and they're very good. We've established that. So there's also the not our problem factor, which is, well, you can't have OpenZFS without an OS, but at somewhere you draw the line of, well, the device naming strategies on OS foo or Linux distro variation 328 do their thing, and maybe it's a little different. One, where do we draw that line? And relating to drawing the line in the whole tar pit of OS differences and device naming and strategies and good practice, blah, 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 is the other extreme. The standards out there, the NIST standard, the HIPAA compliance, the SEC, the whatever bucket of financial fintech standards, trusted partner network from MPAA, all those. They are vendor neutral, but I'm guilty of writing documentation and blog posts for a vendor, and it's good information that gets maybe dropped from the public when that version of the described OS appliance changes, but the facts might still be valid. So a key point I'd like to explore is vendor neutrality. I trust that the post-Sun Oracle manual pages are vendor neutral. Are there any cases where they're not? But then stepping out to the wiki or otherwise, or whatever the future thing is, how do we maintain that vendor neutrality from all the vendors in the room who we love dearly and often have a budget to work on documentation, but slapping it with your banner at the top is sometimes backfiring when it's an old version, you change the product name perhaps, and the information's still valid, but oops, the documentation goes away because the product has changed.
Yeah, as somebody that's trying to write portable, recovery and backup software, it's almost impossible to do what you're suggesting. So for example, there's slight divergences between Illumos ZFS right now and the primary OpenZFS repositories. I know that that's going to be either a hackathon topic or tomorrow topic, I think?
Today, later.
Oh, great. Yeah, so there's just like very, very slight differences, but they were definitely enough to be slightly confusing to somebody who's been around the block.
Well, yeah, like even in the man pages, I know Brian and I have talked about, like, do we need a preprocessor step to have if-defs in the man pages? Because it's like, the vol mode property on a zvol has values that are specific to FreeBSD that only apply if you're on FreeBSD. Or, the default for certain set of, like, at one point, I think the default for trim was different on FreeBSD than on other operating systems, just because of, the separate trim feature that was on FreeBSD before and so on. And it's like, even the man page is trying to either not pollute them with, like, well, if you're on FreeBSD, it's this, and if you're on Linux, it's this paragraphs.
I couldn't get CFS jail to work at all on Linux.
Yeah, because it's called, we kept the name Zone, like on Solaris.
Exactly.
And yeah, it's like, it helped a little bit when we broke the jail man page into its own subcommand, but anywhere where it's cross-reference, it's like, yeah, you almost need to if-def in your man pages, and that gets really gnarly. And how do you maintain all of that?
Yeah.
Jan does want to half suggest putting a support chat bot on OpenZFS.org.
I crossed my mind.
Yeah, but there's just as much risk that it gives you the Reddit answer that's wrong.
Well,
Trained on itself.
yeah, trained
Sure,
on-
but like we said, it always depends, right? So like if they ask what record size should I use for my Postgres database, it turns out the answer depends on what's in your database. Is it a log of financial transactions where old records will never change? Then a bigger record size will give you more compression and more caching and better results. But if it's something else, then you want the smaller record size to get more performance. It's like part of the problem with the documentation is there usually isn't one right answer.
That's the lawyer angle. It depends. So the manual command could actually just say it depends. Just leave it at that. Just good luck. So it's a challenge.
So, and one of the approaches that's taken in some other fields is that you can have a sort of central generic document and then a separate document that says, well, this is how it's different in scenario X, Y, and Z, which is harder to maintain.
And, you know, you always have the risk the user's not going to read the addendum.
Yeah. Well, I mean, you know, obviously it depends on sort of where the user is coming from, because
Yeah.
some of them will read the addendum and they won't read the
Original one either,
Yeah.
yeah.
But, you know, but at least I think if you have sort of that idea that there are always going to be, you know, some things that are core to OpenZFS and other things that are going to be either platform or application specific, then, you know, you at least have a better chance of not getting down into this tar pit where you have, oh, well, if you're on Linux, you do this, and if you're on FreeBSD, you do this, and if you're on, you know, platform Y, you do this.
Or even FreeBSD 13, 14, 15,
Yeah.
it might be more fine-grained than that.
Yeah.
Chris?
I was gonna say, we have that problem obviously with all the different versions of TrueNAS and then the underlying ZFSs. You know, there's docs tricks that we employ to get around that. You know, you have all the info and then a choose your own adventure section with the breakout details. It's a pain to maintain. It's tough, but again, we've recognized the reality that most people aren't gonna read it. That's purely just there for the doc spot sitting in front of it to read and then ask you the question, what version of TrueNAS are you on, or what's your environment, and then it'll hopefully provide the answer out of the right choose your own adventure category.
Yeah, I mean, nothing's going to be perfect. I mean, even like SSH options between like, you know, TrueNAS Core 11 and 13 need a little bit of tweaking. It'll work, of course, but it needs a bit of tweaking. So, I mean, if SSH can't, you know, can't do a 10-year period without needing a couple of tweaks, I don't think we need to be perfect here, but I think within the last few years, it would be great if there was a single source of truth.
Maybe on a kind of tangentially related thing is, like, are there things we can do to make ZFS more supportable? So that when somebody does run into a problem that's maybe not just a basic documentation thing, that they can give us more information about the situation they're in so that it would be possible to answer their questions more
Alan?
easily. Kind of like the, maybe a lighter version of the debug dump that a TrueNAS gives.
What's your gold standard of supportability from an appliance you own in your home to a software project to a thing? What can we aspire to follow?
I don't know that I have a good example. You know, the cobbler's children have no shoes.
Yeah, I mean, so pretty much all of the network hardware vendors that I deal with, like the CLI just comes with a command that says, you know, generate a support thing.
Yeah.
And, you know, I can easily see that you could just, you know, ask the operating systems to ship with a script that just, you know, collects a bunch of information about, you know, what kernel do you have, what, you know, OpenZFS do you have, and, you know, what pools do you have, and all of this stuff, so that you can just say when someone's filing a bug report, please include this information, and you can automatically parse it out rather than, you know, expecting the user to sort of, you know, rephrase it in English.
Right, like I think Brian has a template in the GitHub for OpenZFS where it asks a bunch of these questions, but maybe if there was a tool that collected a bunch of that to kind of pre-fill out that template in a more standard way, because the users tend to free-form it a little oftentimes. So yeah, maybe we could include a shell script that would just spit out, here, copy and paste this at the top of your bug report, and it'll tell us what we need to know about your system. But we'd have to think about what else goes in there other than, you know, ZFS user space and kernel versions, because how many times have we seen a mismatch there cause all kinds of havoc?
And what's actually, what you actually can share.
Sanitization, yeah.
Yeah, and well, because a big part of that is, don't post this to GitHub for me. Give me a thing I can copy and paste so I can edit out what I want or whatever. But hopefully we're not capturing too much where they're going to want to edit stuff, because, you know, we've all seen the bug report where they tried to change the IP addresses and forgot 2 instances of it, and then it's like, well, that's not the same subnet. No wonder it doesn't work. It's like, well, that's just my search replace was bad.
Well, I mean, at least with some of those things, you know, if you have a script that's actually outputting that information, you know, you can do, like, for example, the same thing as the, what's it called, the dmessage server does, and just recognize some kinds of information that should just always be redacted and don't emit them.
Yep.
That's a lot easier to do in an automated way than it is to expect a user to do all the time.
Yep.
But on the other side, if I get a call from a customer, I know I'm already in their network. I know their IP addresses. If they're giving me redacted stuff, I still have to go back and research it. So it's literally a flag of this is for outside world, this is for inside world, or trusted support versus anonymous support.
I think to
That's a good
some
point.
degree, some of the problem with the question is we have the issue of what kind of user are we talking about? There's a huge difference between someone who's using an appliance in their home and me operating in my data center using a completely custom stack. Those are not the same users.
Yeah, or even just, the user who's responsible for admitting this ZFS box, but storage isn't their day job, or, the other person who's like maintaining this big storage array is my whole job. And there can be a big difference in not just the information they have and how they would share it with you, but how you'd want to aim the answer back to them.
And a lot of people are going to want the most real-time option possible. I mean, I did a lot of my learning on IRC, which, is not super well populated. I'd ask the audience, or Alan or Michael, do you know, I mean, I use the Wednesday calls to call for testing.org. Yeah, the Wednesday calls, I join those to talk shop. That's a great resource for me. But I don't know if there's a Discord, this Practical ZFS, that's a really good forum, which is probably more reliable than Reddit at this point. And there's a lot of traffic on Reddit. And yeah, but I don't know if there's any, I mean, I go on the FreeBSD Discord sometimes and chat about storage. There's a lot of knowledgeable people there. But if there was a, official OpenZFS place to chat besides IRC, because IRC is not going to get the youngins, I don't think.
It's not even going to get some of us old uns.
So, the true problem, for those not seeing the room here, there is not a single non-developer or administrator here. All of us, the people in the kitchen, work at vendors, pushing products and doing wonderful things. So, if you're in this room, by definition, you don't have a lot of free time. Is that accurate? I see a lot of nods. And by definition, also looking at you, Garrett, especially, the wisdom for all of this is like looking like this. It looks like you. You have that wisdom. You are the people. That's us. That's it. So do we set aside a tiny amount of time, be it every year at a developer summit, or somehow in our workflow to work on the commons? And that's a word I think I'll be using a bit this next 72 hours, in that the commons are critical. We wouldn't be here without the commons of ZFS and now OpenZFS. We wouldn't be here with our different Unix operating systems, and looking around the room, we have many represented. So we agree it's hard. We agree it's a challenge. We agree there's need to it. So as we go through the next few days, let's think about what we can practically ask of all of us, because choosing someone in this room to clean up all the docs is a horrible idea from both those hoping for progress and those being that person. So I'm all ears of how we can improve, but please just think this through, think the good examples inside this project and outside of it of gold standards to follow. Is there a read the docs for OpenZFS or not? There is? Goodness. I see one nod. Alan?
Well, I think it's mostly, there's a OpenZFS docs repo, so it's like OpenZFS.github.something.
Okay, go.
For example, has the getting started docs that describe what packages you need to install to be able to compile ZFS or use the test suite.
Or needed 3 years ago. Okay. So, that said, please, everyone just think aspirationally about what we can achieve realistically within the confines of our time limitations, our vendor limitations and their motivations, our passion for things like Unix and related operating systems and the file systems that generate from them, wisdom from other projects, and I will let you two handle closing thoughts. And Sue, please.
So those of us that aren't developers, me, or anybody else, yeah. If we want to set aside some time on Tuesday and frame this out, so it's at least we have a framework around it, and then we can start adding stuff. And you know, if we're using 20 minutes of the weekly call to review that kind of stuff, or say, hey, we need this, and just populate it that way. Why wait? Let's start now.
Yeah, I'd like to say that there's a lot of ZFS users that aren't of our of our skill level, and there's so many people who have a couple of years in and are system administrators in their own right, but have a couple years. They've taught their first person at the job how to use ZFS tools. Those are the perfect people to assist with documentation. That multiplies the number of contributors that we could have by 1,000 quickly. And yeah, so I don't want to say that we have to be necessarily, I mean, we have to be the ones that edit it, but we don't have to be the ones necessarily that make corrections.
Right, but exactly to the kind of point we had earlier, it's like, where do we find all these people? Because I think they're kind of fragmented across Reddit, Practical ZFS, Discord, IRC, Slack, and mailing lists and everywhere else. And like, yeah.
I don't want
to
complicate this further, but looking at the remote participation, I see a native German speaker. I see, I believe, a Japanese speaker. We haven't even touched on multilingual support and what that can look like, because
how much demand is there for that?
if anyone on the Zoom session would like to chime in on your experiences, you're an equal participant as best we can. What's that?
We let the AI,
Sorry
AI
to
handles
be-
Aim
that
the AI
for us.
at it?
Our docs are in English. If you want it in German, just ask and it'll do it for you.
It'll do it. Okay, Jan, what's your take?
I don't think there's a lot of need for German documentation because those working in these fields in Germany are expected to be able to fluently read English technical documentation.
Yeah, I think the tools surrounding translation hopefully will continue to get better as they are. So maybe we can solve that in a sideways way. I think souping up, I think open-cfs.org is the place that people are going to end up if they're curious about it, and it's not an inviting place. So, as you said, who is in charge of that? We must, find a mirror and look at it. But I do think that there needs to be a spruce up of that. There should be production user, in addition to the production user call, there should be production user way to chat and a production user mailing list maybe. So I think we're missing some of those things that could get much more engagement by people who have not been breathing this stuff for over a decade.
Any final thoughts?
Yeah, I'll say that from my previous company and my current company, there was a common thread. We use Sphinx to write all the documentation, including the man pages, the web pages. You can do a lot with it. I don't know if that's what you guys are using right now, but I also like the idea of just sending it to AI, but somebody's still got to take a look at it, to make sure it's okay. But either way, if you're going to embark on, we also have a couple of full-time people that do nothing but try to figure out how to feed the AI engines of various sorts to keep Bacula. If you do a search on backup, this and that, Bacula will pop up, and that's been improving greatly over the last couple of years. So, getting everybody to know how to do that is hard. I don't know how many people you have that work just on small docs team. Yeah, just a small docs team that are just dedicated to that. So to some extent, you need some people with some expertise in that area. But I would say that maybe coming up with a platform like Sphinx and then a dedication to, as you're feeding information into figuring out how to format it for the AI, not for the end user, so that you get that, you get the proper kind of scraping, are two things to consider.
Yeah.
Close it out. You can close it out. Like and subscribe. Oh, wait, hold on, wrong one. Thank you, everyone. We'll meet at 11 for the next session. Thank you.
Thank you.
Thanks so much.
Daniel?
Oh, is Jan talking to me?
Yes?
Hey, Jan.
Now that you finished,
I pulled it down.
Recording in progress.
Oh, let me get a doc going. So Chris, come on up nearby if you could. Docs. Oh. Ooh, do you want me to share this? Which I'm happy to do, but that'll take me just 2 seconds. No, better yet. Go away. It's as if there was a place for this. There's that for you and guests. I'm going to hide that. So I will just hijack the public. For those who knows what this means, the production user call doc will simply be where to discuss this, as I do on a call, because that's the tool of the hour. So view. For once, I'll use full screen. I'll zoom in. Am I on the? Am I in back? Yeah, you're on the screen. Great. Thank you, audience. But hey, this is not a marketing event, and we are not as polished as the great marketing teams of the world, and that's by design. Deal with it. So you've got me and this laptop rather than booth staff. And there's a whole summit doc. Actually, I'll just punch that sucker down and get going. Are we streaming yet? We are. Okay. Hey, stream. How you doing? Learning how the sausage is made. Yes. OpenZFS 3.0 goals and quality. What do I call it? Quality strategies. I misspelled already.
It's hard to type when people are watching.
Yeah, well, it's a multitasking. Yeah, you join the calls. Have you joined a call?
I have not yet. I need to.
Show of hands. There are like 20 of us in the room. How many people have been on a production user call? 1, 2, 3, 4, 5, 6, 7, 8, 9. Rod took off. 10, half the room. So yeah, every Wednesday at 2 p.m. Pacific now to accommodate Rob in Australia. And good stuff happens, and okay, I'm going to start the session with a little pitch about myself in it, because I ignored that at the beginning, because this is not my event, this is yours. So, welcome, stream, welcome, people in the room. Once upon a time, the Beehive hypervisor had a developer call about the internals and the really deep stuff about it. And then once that opened up to a broader audience, we found ourselves discussing OpenZFS for like 90 more minutes because, well, everyone's using OpenZFS. So then that sprouted a dedicated OpenZFS call, which has taken place for a good 3 years or so. They are wide open for participation. The document is right here. You can actually, you can vandalize it live on the stream if you like, but please don't. And then they're recorded unless it's sensitive, and they're published such that if you put a compelling question on there, then we will probably read it and say, that's a great point. And we just pick our brains that are at the table. How's that working, Stu? Cool. So actually at this very moment, I will reduce the sharing, just thinking out loud, just for, remind me to turn that back to normal. Anyone with the link can comment. Okay, cool. So that said, every Wednesday at 2 p.m. Pacific is the OpenZFS production user call. It's different from the leadership calls. And thank you, Alan. It seems like you're following those. Alan, what's the schedule of those? And I'll repeat it. Or you've got a mic. Hang on, perfect.
The ZFS leadership call is once every 4 weeks on Tuesday, alternating between, I think it's 10 a.m. Pacific and 1 p.m. Pacific to try to accommodate time zones.
Fantastic. So for our next session, we'd like to discuss early on the concrete and aspirational goals for the OpenZFS 3.0 release. We are blessed with having Brian B. in the house and Chris Moore, who has some goals, and some of the most amazing staff to improve this product, and along with all of you and your amazing experiences and developers. So let's kick it off by exploring how you define the notion of user space, OpenZFS, and what we hope to see in 3.0.
Sure. So, user space, OpenZFS, right? It's something that's been discussed at previous conferences, so this isn't necessarily a new topic. I have two different real primary drivers for asking for this on the TrueNAS side. Is I'm concerned about the overall longevity about ZFS as well. I'm looking at the macro picture here. I want to see it in more people's hands, and I want to see it become the file system of choice for most systems around the world, right? TrueNAS, obviously, we try and put ZFS in everyone's hands, and I think we've been remarkably successful at that. But, you know, we're a drop in the bucket when you look at the wider Linux ecosystem. That's just a fact. You know, we all have to recognize that here. And I think getting ZFS on more distros out of box by default is important. I think to make this grow, to have these events be huger, more developers, more companies, more vendors, I mean, that's important. We should care about those things. Otherwise, it just turns into a niche hobby project over time. And so I have those concerns because I don't want to wake up in a world 5 years from now where it's like, oh, Bcache got their act together. And, you know, now it's becoming interesting, and guess what? There's a lot of vendors behind it, and ZFS is looking like the, you know, yesterday's solution. I don't want to be in that situation 5 years from now on the TrueNAS side, and I think most of us in this room don't want to wake up in that situation, or ButterFS or whatever else, you know, might happen in the meantime. So we've talked off and on over the years of, oh, we can go to Oracle, maybe they'll relicense it and we can fix this. That ain't going to happen. Like I said, I put that at a 0% chance approximately. So let's not, you know, fool ourselves or use that to kick the can down the road and not do something about it. So from my side, on the TrueNAS side, I think there's two real ways to do this. I think user space ZFS is probably the first way, just to kind of sidestep the whole kernel licensing discussion, period. If you have a pure user space implementation, we don't have to worry about kernel pollution. Distros will be a lot more eager and open to adopt it. It just kind of makes that argument go away. Now, you do that potentially as a strategy, you have a lot more users now clamoring for a kernel module, again, for various reasons, and now there's some motivation to go and do like a GPL implementation of the kernel bits. Okay, great, but you know, crawl, walk, run. I'm like, let's start off somewhere that's achievable, and I think user space ZFS has another interesting angle in that we're keenly interested in being able to run containerized ZFS, different versions of ZFS on the same host and not care what kernel you're running necessarily. That's very interesting for a lot of different reasons. You could probably imagine some replication targets. Can you imagine if you could have a box and spin up, yeah, what version do you want to replicate to? Great, here you go, here's your container, move on. So again, I've seen work out there. I haven't seen anything land, obviously. We would be interested in talking if that's something that any other vendors here or individuals are interested in contributing towards. I think long-term, that's a good strategy for the project. Is that a good enough summary, Michael, what you were looking for?
Are there other definitions of user space, OpenZFS?
I didn't even mention performance. I mean, obviously, we all got a lot of user space applications. It would be nice to avoid the hop. So.
Yeah, I know there's been some interest from people in like Postgres. It's like, you know, if Postgres could interact almost more directly with the DMU of ZFS or a user space version of ZFS to store stuff on disk, then it would take away a lot of the challenges, especially with, you know, the way fsync works on Linux compared to how it works on BSD and Solaris and so on. And just there could be interest in there about just the right way to incorporate all the values that ZFS provides into other use cases, like, you know, a database engine or whatever other application that would, you know, benefit, especially when there's alignment with that kind of transactional nature.
So I think there are two ways we could have a ZFS in userland. One is we have ZFS at home where we get known as the slow file system running as a Fuse server. It would be really useful for maybe migrating data and getting onto obscure platforms, but it shouldn't be acceptable as the way you run ZFS on Linux, I think. The other one is taking advantage of the fact that the CDDL is not viral across files and allowing applications to embed ZFS to directly talk to disks so that you have a library file system an application like Postgres could use to directly talk to disks and talk to DMU maybe directly.
Yeah, that is definitely
Those are very different definitions of user space, I think.
Any other questions or comments?
There are two questions that you can't see from here, but I'll read one of them for you.
Sorry.
How much code would end up duplicated, and how much would be truly shared between a kernel version and a user space version of ZFS?
Hey, you guys will have to tell me. I'm not the developer. That's the best part.
Yeah, so I'd like to think we could do it in a way where it's a lot of shared code, right? We would treat the user space implementation as just another platform, basically. And we just happen to build it all in user space. And I think what we talked about are all really good models for it, right? You would want a fused implementation, because that would just be shippable in Linux distributions. It would just be there and work. And we'd avoid all those issues.
And it's just another platform to be able to test that all the user space parts are working right?
Yeah, exactly. And you could build it all in user space. There's a fair bit of work there to like integrate it with Fuse or whatever, but I think that's all doable. And I think that fits really nicely in a OpenZFS 3, right? Because it would be a good time to add a new platform or look at adding new proper first-party platform.
And just putting my corporate marketing hat on, it's real sexy to be able to announce that in the 3.0 as well. Like that'll get some headlines.
Yeah. I think there's also probably a bunch of really good use cases too for using the DMU directly. Like databases are an example. A case that's interesting to me are like distributed file systems where you don't necessarily want all of that to live in the kernel like we do with Lustre today with it's in the kernel, but you could imagine it all being in user space here. User space, well, even not distributed, but an NFS server or, backend for another distributed file system. All right, so we've definitely seen interest in that over the years.
Is Ganesha getting much attention in 2025? Because apparently it's user space, and it did Plan 9, it did NFS, it did all the things.
So we're using the in-kernel NFS server these days on the TrueNAS side, but who knows, maybe we revisit that down the road if this happens.
Well, especially, if you have a user space NFS server that's, linked to a ZFS user space library, basically, and just talks to the disks from user space directly, then, it can do a lot of things without having to go through any of the VFS layer and so on.
Let me pick on our Samba expert in the house now and see how would that impact you on the Samba side? Does it help or hurt anything?
Well, I don't really have a good answer right now. It would probably just be a matter of having to look at how the APIs are. It's kind of hard with some of the things with Samba because a lot of Samba is single-threaded, so there are considerations.
And there's, I forget the name of a new project I saw on LinkedIn a couple of weeks ago where somebody built a user space NFS, SMB, and I think iSCSI in another language or something. But if that could then use user space ZFS to do the bits underneath, then suddenly you could have, a whole NAS that's all just user space and could run as an application on any machine even.
That would be very interesting.
If I remember correctly, Samba has a backend plugin to directly talk to Ceph through the Ceph-specific protocols rather than the fuse mount and so on. So if something like that were to talk to a user space ZFS, you could have a Samba server which does not have to go through the kernel of the host, but instead you have ZFS formatted disks which are only accessible through Samba. It may have some advantages when it comes to allowing Samba to be more efficient about locking and providing the semantics the SMB protocol specifies.
Yeah, so Samba does have a very rich VFS layer, and they already implement some user space file systems like ClusterFS, for instance, and you mentioned CephFS. So in theory, yeah, if a user space library is provided, it would just be a matter of developing a new Samba VFS module. It's pretty well documented and not too difficult to write a new VFS module in Samba.
Another question, if you have a user space, especially an application embedded ZFS in user space, is how do you administer that? How do you make sure someone notices if a disk fails and needs to be replaced? How would you create snapshots if the application doesn't do it all?
Yeah, I think those are all good questions and challenges. Like we'd have to somehow extend the existing tool chain, I think, to be able to interact with the pools with the normal ZFS and zpool commands. What that it looks like exactly, I mean, that's one of the challenges why this hasn't happened yet, is it's easy enough to do some of the basic stuff and get it wired up, and then you start hitting these other challenges about, well, what does this look like in reality for a user? How do you manage it, right?
For the ioctls, experiment with basically using a socket instead of the dev ZFS device. And you can send all the articles over a socket, but that leaves the whole VFS layer as your problem.
Yeah.
But, you know, but for a lot of use cases, like you said, even just a replication target, you can not necessarily need any of those parts, right? You just need the stuff you would get from the user space implementation we use in the test suite, basically, just built out and not quite as constrained as the version for the test suite.
And we will talk about object stores and perhaps an S3 front end later. So let's talk about other features completely unrelated to user space ZFS and the aspirational OpenZFS 3.0 release. Thank you so much.
So, well, yeah, what else do people want?
And that's literally you. What do you want? What are you working on that you want to get in there that would help you in your job, your product, your whatever, your life, your hobby, what you name it. And if anyone wants to join me up here with a whole bunch of those in mind, welcome. Rate limits? Tell us more about rate limits, and you might have a mic there, or you might need to share. Well, yesterday is not streamed to all these wonderful people. I will bring you this mic and just hand it around as needed.
What I'd like to make it into 3.0 is data set rate limits, so that we could solve the noisy neighbor problem, and for at least the VM workloads that are running on OpenZFS, you know, you want to restrict one VM from taking too much bandwidth, right? So that's one feature I'd like to see. And there's already a pull request for it that's very, very close. So,
like, is there something you'd like to see on top of what's in the pull request? Like, are there missing pieces?
No, it just when it makes it in, let's include it in 3.0.
Want to just jump in the reviews APR would help.
Sure.
Is it still on the pen board there?
No.
I think you had a number. Are there other strategies other than rate limits to address the noisy neighbor problem?
So Joyan had a version that just ensured that everybody got an equal share. It wasn't as prescriptive as the hierarchical rate limits. It was just more a fairness algorithm, but that's one other possible approach, and I think the code for it is posted somewhere in their old Joyant repos, but I don't know that anybody's done anything with it.
Alan, how about per VDEV and QDEV configuration, so that if you have a pool, especially a hybrid pool, you can, or multiple pools, one of spinning disk, one of flash, you can specify different
we were talking about that.
QDEVs.
Yeah, we were talking about that recently. Yeah, that was always one of the ideas behind the per VDEV properties, was to be able to do that. I think the first thing we have to figure out is what the inheritance rules should be between the top level VDEV and its leaves, and also like what happens if you know, even temporarily are doing like a replacing VDEV or a resilvering VDEV and so on in between. How does all that affect inheritance? But yeah, that's, you know, if someone had a specific use case for that and wanted to help drive funding for that, then it's definitely something that's on our to-do list.
Hopefully simpler intermediate step, which would already solve my production use case, would be to make it a per pool setting instead of a system-wide setting for the whole kernel module.
Yeah, we were talking about that for the dirty data max as well, but some of those properties have a default that's system specific, like it's a percent of your RAM, and pool properties are not very conducive to that, but you also have the problem of, well, if you have 8 pools, you don't want each one taking 10% of your RAM, because then you only have 20% of your RAM left. And so trying to make even those values scale, like even the tunable based ones we've seen before with like, I think it's the number of threads for the ZIO task queue or whatever. If you have 7 pools on a system and each one of them is using 25% of your CPUs, you're now oversubscribed on CPUs instead of leaving some CPUs not consumed by ZFS as the default intends to do.
Is that
But
one
that
right
wouldn't
now?
apply to the QDepth.
It doesn't
The
apply to QDepth,
QDepth
but it
is
does
not
to
a
ZFS.
shared resource
Right.
of the same type.
At the data set layer right now, can you tune it live?
Tune which?
Well, what you were just describing of the.
The zero thread thing? No,
Yeah.
there's one system-wide tunable, but the percent you apply applies to every pool separately.
Right. So what I would like to see is being able to push some of those tunables to the data set level so that they can be turned on and off during specific workflows.
Right, it depends on the tunable whether the data set level makes sense, but yeah, that's.
Because I have a very heavy write system going for 12 hours.
Mhm.
I need it tuned for writing only. After that, it's a normal process for 12 hours.
Right, but like the tunable Jan's talking about here is for the QDepth to the physical disks.
Right, no, I
And so
get that.
that's
It's
below the
more
data
of
set.
the, everything that could be tuned if it can be dynamic versus a
Yeah.
kernel remod, or until it gets into user space, it's a kernel remod to pull it.
Yeah, and in particular, like, one of the recent great examples of that was making, disabling prefetch be a per dataset property instead of one system-wide property. Because, you know, you may want prefetch on most of your data sets and just not on the database and things like that.
Exactly, yep. That's my main
And, you know, that's a lot of housekeeping that, you know, just going through every tunable and deciding what the scope of it should be is a great objective, but, you know, doesn't necessarily land in anybody's commercial use case.
On that very topic from yesterday, in this notion of configuring it to your use case of the hour, was the reporting that we wanted to extract for diagnostics, et cetera, where you can get all and get drowning in information. It's very heavy and expensive to retrieve all that information, but typically you're after hopefully one narrow target there. Is there work that relates to OpenZFS 3.0 that is reporting related that we can kind of promote here?
It comes back more to the collecting more from other people who are using ZFS of like, are there metrics that don't exist or are hard to extract from ZFS that would be useful to have? But I don't have any off the top of my head really, other than maybe the VDEV latency stuff, which is in zpool IOStat, but not in like a kstat. And that might just be exposing that via properties, per VDEV properties, like we do for the overall VDEV stuff. Although, how do you display a histogram as a property?
Well, we have properties for the delegation and permissions, which are tables. So you
There's no
could
property
have
for
basically the
permissions.
histogram as a property, which has a table structure. Just like right now delegations and so on have.
Those are not properties.
They are returned as that in the, sorry, not the projects, not, yeah. Let me check the channel program API for a second.
Wish list items that, while he looks that up, regardless if they're progress, some new idea that's occurred to you yesterday, or something you've long wanted, just let's throw them out there while it's
Stuff that we
early.
have, at least at the top of our minds, if not going to be in progress, is an FSCK for ZFS. Basically checking directory file system consistency, being able to relink the unreachable files from a damaged directory. Again, usually caused by a hardware problem, not a ZFS problem, but if the data is not readable, then you can't walk into the directory to see all the files that are there, but all the files are still there. ZFS has everything except for this one broken chunk. Can we relink those damaged files and get you access to those again?
We had a very fascinating discussion on ZFS diff, and I believe a bug of abandoned files. Do one of you remember that, Stu, or otherwise, or Jan, I think? Maybe you can check the Well, it's technically on the same dock here. Let me see.
It wasn't on my original list, but one thing that FSCK could do is notice when the parent of an object doesn't match up anymore. So right now the problem you can have is if you have multiple hard links to a file, every time you make a new hard link, that becomes the new parent for that object. And so if you make the hard link and then remove the newest one, ZFS can't easily figure out what the file name of that file was anymore because the parent is wrong. And the FSCK, while walking through, maybe could correct that, although that wasn't, on the top of our list of things for this to solve. But it would have the context to be able to do that.
Yeah, we talked about that at one of the user group meetings.
Yes, please.
If at the time that you discover that a inode is missing a parent, you have no idea where to link it to. You could optionally link it to a kind of a lost and found type of an area to recover it. But there were some other ideas for fixing that. I think there's a couple different approaches, but essentially having more metadata that anytime the link count of a regular file goes above 1, you keep track of it in like a new structure. And
Nutanix had a patch they demoed in I think the 2021
yeah,
2022.
There was a couple of different solutions that were kind of in place, but none of them had been sort of completely adopted because it's not such a big issue for everybody, but
yeah,
it is for backup.
So yeah, like FSCK, you said, like if the parent points to nowhere at the moment, as we're walking other directories, we'll find that inode and what its actual name is and what its, one of the other links has a name that still exists, and we could update that parent field. Not that we want to be touching every directory unnecessarily either.
So actually that sort of reminds me of a couple of things that are related to backups and related to the work that Chris has been doing with us is machine readable ZFS diff output. And also, this may be related to the thing that we were just discussing, but whatever the hell it is that you're running ZDB-DDDD and parsing the output from to figure out, some way to not do that, because you really shouldn't be depending on the output of ZDB to run a production anything.
Yeah, for sure. We've thought about some kind of IOCTL or FNCTL or whatever to get some of that information about that. Not one that I have on my list to do, but one we've thought about before was getting a checksum of the checksums of all the blocks. So be able to ask ZFS, like, just sum up the checksum of all the Uber blocks for the level 0 blocks in this file in a way that I could create the same checksum in user space by just knowing, the file has this block size, so I'm going to checksum each block of that size and pad out the last one with zeros and get the same checksum, but in a way where I can verify the checksum without having to read all the data. It could be interesting, but basically other things we can do where you can ask ZFS for information about a file, whether that is just the per block checksum or this kind of aggregate checksum, or just, hey, what is the record size of this file? And especially if we ever get to being able to have an application say, I know the data set says record size this, but I, as the application, happen to know that this file needs a different record size. Can I, give that hint to ZFS as I create the file, saying that, I want a different record size. And then you have the question of, do we need a different property where the admin could say, I don't care what the application says, this is the record size. We have the default, but maybe it's almost like the direct IO where it's like, yeah, the application can ask for it, but I can also say no if I want, kind of thing.
Did I hear per file record size,
yes,
hypothetically? Oh boy, cool.
Again, that's more of a wish, like, I don't even know if that's useful, but if somebody has an application for it, it is another thing that ZFS could pretty easily do, but it would just take someone doing it.
Let's go with Mav for a sec. Hold on, Jan. Let's go with Mav. He's been quiet.
Just to previous idea about ZFS providing information, would we have some interface to do that? I was thinking about reporting, okay, for this specific file, like how how much data stored on different tiers.
Yep.
Is it on special,
Different
normal,
VDEVs, tiers, specials.
maybe compression per file, something
Kind
else.
of, to Garrett's point, all the stuff you would normally have to use ZDB-DDDD and have a lot of information about what each VDEV number actually means as far as class and so on to be able to answer.
Yeah, just question, where can we generally even report that, other than some custom extended attributes I can't even guess?
Yeah, the
what API
file
could it
map
be?
interface in Linux, but I think even that is not quite as expressive as we would need, right?
Yeah, so Linux provides a FileMap interface, which lets you show extents for files, basically, with some additional properties and statistics, but it really could be extended, right? There's more that we want to represent there than is baked into that current format, but it would be a good starting spot, because a lot of existing tooling knows how to read that information.
How's that spelled?
FIEMAP.
Like that?
So,
Yeah, I don't know why
I
it's
think
missing the L.
getting the sorry.
Go ahead, Jan.
I think getting the ZFS checksum of a file would be very useful to non-ZFS backup tools like Rastic, Borg, and whatever.
Yep.
Because they could efficiently find out if the file could have changed and they have to do their content chunking and deduplication logic again, or if it is exactly a file they already have.
Well, to Stu's point about the archive bit, one of the things we could expose is just the transaction group number the last time the file changed. I think it's called the generation or whatever. ZFS has all that information and could tell you, this is the last transaction group in which this file changed. It's kind of an implementation detail, and Rustic or whatever would have to kind of keep that metadata on its own on the other side, but it could do that with an extended attribute on the other side. But it reminded me of, to Garrett's point, a more verbose version of ZFS diff that instead of just telling you whether the file changed or not, it could tell you what byte ranges in the file happen to have changed. Kind of halfway between a ZFS send that sends those blocks and a ZFS diff that just tells you which blocks it was. But yeah, ZFS diff-VV or something that would include in the JSON machine-readable output, not just that this file changed and these are the ways it changed, but also these are the parts of the file that changed. For small files, maybe it doesn't matter so much, but if you're trying to back up a the VM backing file, then it's possibly a 10 terabyte file and there's 1 gigabyte of changes in it, but those changes are spread all over the place. If you know which blocks changed, then your backup can be almost as efficient as a ZFS send while still using a non-ZFS backup thing, like whether it's rsync or Bacula or whatever.
Also, right now, ZFS diff does not support JSON output as far as I know.
Right, Garrett added that to the list earlier. It's up there. Yeah, it's the third one on the wish list.
I will say that modifying ZFS diff to give offsets is probably a hackathon scale project. Like, it's not that hard, so if anybody's looking for something to do on Tuesday.
Another one, I don't know how many people have run into this, but has anyone ever seen an IO go off into the Linux kernel and just never come back and ZFS sit there stuck? Could we do something in ZFS to make it be able to just give up on that IO and consider it failed? And then what do we have to do when it maybe does complete later? It's like, we don't want to add another layer of task queues or something, but if we have to have like a non-synchronous interface to dispatch stuff down to Linux.
Yeah, things have gotten much better on that front in the last couple of years, but it definitely still happens where you lose track of an I/O on the system, right? And usually it's because the kernel, it either needs to succeed, fail, or time out. And if none of those things happen, you end up at a bad spot, right? Currently. Yeah. So yeah, I mean that's definitely something worth looking into. If there's some way we could just orphan that I/O, just treat it as a failure, but track it internally until one of those things eventually happens, because that's typically where you run into problems where, you
is scary because if it completes later, you need to be able to actually cancel it.
Yeah, well, you have to.
Yeah.
Well,
we have to
like
track
you
it
have
at
to
some point.
keep track of this and not use that allocation again for,
Right. You have to return it as an error early on and say, like, it failed, and like, if this thing actually completes in the next 3 days, for whatever reason, I can still handle it cleanly internally, right?
right, but we have
The
to make sure
trouble
we
is-
don't reuse it and write something else to that location in those next 3 days.
Yeah.
It's now dirty.
Yeah, it is, yeah, on our orphan list of, we can't allocate to that until we reboot and are in a known state or something.
Orphaned rights.
I'm sure there's a solution for
Q.
the lost ZIOs, disk IOs, but maybe we could look on interruptibility of user calls, syscalls. If somebody requested read and got stuck, the Control-C should abort it potentially.
Yeah,
Maybe
and
at
we've,
some points.
you know, all seen that, you know, somebody's running zpool import and it's having a problem, or it suspends during import, and then you can't run ZFS list or zpool list on any of the other pools because it hung while holding stuff, and there's no way to even cancel the ones that haven't started yet. Like I think my
But what
hackathon
would-
project 2 years ago was I made basically the user space side would make the ioctl, and the ioctl would like try lock and return with an error, and user space would just loop retrying so that you could Control-C out of it. But I didn't go and do that to every ioctl yet.
It's probably just one at a time, but
yeah.
it would be great to do.
Exactly.
What
Yes, Jan.
happens if this abandoned ride is to an Uber block?
What was that?
Well, if we mark it as failed, then ZFS will try to write again. I guess it's a different problem if it's in the label and we aren't going to be able to just allocate it somewhere else instead.
Because
So
then
I'm
you, I
noticing-
think, have to increment the transaction number, because otherwise potentially afterward, if the ride goes through, you would have two blocks with the same, it's in
Yeah, but
different
ZFS is smart
locations,
enough,
and-
it would read what that points to, and if the checksum of one of them was right and one of them is wrong, it'll do the right thing.
So I'm noticing, looking at this, that none of this looks backwards incompatible. So is there a reason any of this needs to wait for 3.0? Which is another way of asking, is there anything you want to break that has to be 3.0?
Alan, you want to talk about block pointer version 2 early?
Yeah, I'm giving a talk tomorrow about, you know, using some of the padding in the block pointer to do a block pointer v2, and that's obviously backwards incompatible, but I don't know if there's a lot of, well, I guess, and we're changing the label, but that we made semi-backward compatible.
I think we really want to go out of our way to avoid breaking the backwards compatibility here, even with the 3.0. Like, it's our opportunity to do it for sure, right? But if we don't have to, then let's not.
Yeah.
And like you say, a lot of these features, you know, certainly wouldn't break backwards compatibility. I mean, major new features that come in, you know, we have feature flags for that. So if you don't want to use a new feature, don't use a new feature. But I think a lot of these could be gated by feature flags.
Obviously, we want like migration paths, but I'm saying that like it may be unpleasant to roll back a particular change. Pointer flags sound like they could be exciting. Is there anything else that would be maybe good to add, but hard to go back to an older implementation?
We already have feature flags which cannot be turned off
Say again?
once enabled. We already have feature flags which can never be turned off again.
Can a checkpoint rollback undo new feature flags?
Yes, because it rolls back
Which-
the whole
But you can only have
pool
one
kind of at a block level.
Correct. Such that, are there hypothetically feature flags that could be reversed through some not too difficult
Well, the thing with the checkpoint is you reverse everything.
Oh, yeah,
by
yeah,
change.
exactly. So are there feature flags that could be selectively, oops,
So,
I mistyped thing and got the.
For
or
example,
yeah.
if you use Z standard compression, it enables the Z standard compression flag, but it has a reference count. If you delete every data set that's ever written a block with Z standard, the feature goes back to enabled instead of active. So if you delete everything, every data set that's ever used a feature, most of the features will turn back to a not yet enabled state. Yeah. But, you know,
But if you've created and destroyed a data set with Z standard, and it's in enabled mode, can you disable from there, or that was a one-way trip?
I think if it's enabled, not active, then you could turn it off, right?
Yeah, you can definitely disable them. But although there's some work that could be done there too, like lots of the features could in theory be turned off, but there isn't support in the code for it.
Oh,
right? Like,
so it might just be a switch that hasn't been
it kind of has
wired
to be
up.
baked in when the feature is initially developed. Like you say, you've got a reference count for a data set, so you know if this feature is actually in use anywhere. So you need to have some way to walk it back. And I think there's still some in the code that, you know, we could get away with disabling that we don't currently allow. So that would be some nice functionality.
Although I don't know how often that comes up.
Yeah. Usually we have to kind of figure that out up front about how you can turn it off safely. But there's additional features too, like there's some ZIL changes, right, that are only enabled for as long as that particular feature is active in the ZIL. And then once it gets replayed, you can turn it off, right? Or it turns itself off, rather.
And generally, we want new features, but oops, I didn't mean that, or I didn't understand the implications of that, and I haven't used it, fortunately. Well, let's just safely turn it off and tell our boss that we turned it off, and they go back, we all get to sleep better.
So maybe I'm imagining 3.0 in a not useful way. If I'm thinking backwards incompatible, and that's not a thing we ever really want, what does 3.0 mean to you?
It's mostly just maybe the bigger reach features. What are the kind of headline things that you would look for? You know, every release is a huge collection of small quality of life things and little features and so on. And, you know, the occasional big thing like, you know, fast dedupe and any RAID and RAID Z expansion and things like that. But what's the next big thing that should be making headlines?
Let me ask the other way, Alan. What do we get rid of going to 3.0? Are there things we'd like to remove and use this as an opportunity to say we've carried that, you know, baggage long enough?
Yeah. Well, if we're making the list here, L2ARC v2. There's references to it all over the code from 20 years ago. An L2ARC that actually, well, maybe uses the ARC algorithm, like it suggests in the name, but isn't actually, it's just an LRU at the moment. But yeah, is there anything else we want to remove? I know we've talked on and off about compressed ARC, whether that should be, still have the option to not use it. I still think there's probably a use case for that, so I don't know about that one, but yeah, to Chris's point, are there things we'd like to get rid of, like any baggage or things that constantly getting in the way of other things, and it's like, does anybody use this optional functionality?
Other defaults we want to change, like for example, disabling A-time by default, enabling LZ4 compression by default on the root data set of new pools.
LZ4 is on by default. Standard attributes are SA by default now. I think we've done most of those, but are there any more? Yeah, A-time defaulting to off is definitely interesting.
Is there a chance to get a way to preserve block cloning semantics in replication? Because as much as I like block cloning, I'm afraid to enable it in production because of the massive footgun it creates, that you can have a backup on a big backup server which you cannot restore onto the original system, even if you just break the pool with fat fingers. If you try to receive it back, the block cloning gets deduplicated and blows up your storage.
I think one of the main features that's ever been removed from ZFS was support for dedupe across replication. Yeah, and so that's the only feature we've ever deleted, and you're like, can we have it back, please? It's slightly different.
Just for block cloning, not for normal dedupe.
I can tell you the one thing for the list of things that I always make sure that I override when creating Z-vaults. Setting A-time for the root of it, setting compression for the root of it, and then setting the A-shift to 12, because I want to make sure that that's always there in my pools.
So speaking of changing defaults, the one thing that I always have to remember when creating a new pool for any reason, UTF-8 only equals on.
Oh yes, that's so annoying. If you forget that, and pick your UTF-8 normalization wisely.
And that's one time creation time set, you're done.
Yeah, I mean, basically.
You only get to set
any,
that on dataset creation.
Yeah, it's like any of the properties that you have to set at create time only, are at least worth reconsidering what the default should be in, the year of our Lord 2025.
Is there a top 5 of those that burn you? I think it's
only,
a pretty short list.
I don't think there are actually 5 properties that are create time only. I think it's case insensitive, UTF-8.
I think it's the UTF, the Unicode normalization, Unicode only, and case insensitive.
Okay. Looking back, are there
I
any
guess
of those that could
technically
be?
you could allow going from case preserving to truly case insensitive, but oh god, please don't.
Can any of those be fixed with the wisdom we've achieved over 20 years that, oh, we made this mistake then and now we could have them dynamic? Nope.
It's all about how the zap is sorted and things, so it has to be set in stone.
Imagine the problem if you suddenly no longer allow 8-bit encoded names, like you have a file system which is 40 years old, got migrated to ZFS and uses Latin 1 in names, or Latin 9, whatever, and suddenly you say, oh, it has to be UTF-8. What do? Do you know the code page it used and map it onto UTF-8 when switching the setting? Or do you delete the files which are not ASCII? What do? There is no sane semantics ZFS could offer for going from allowing non-UTF-8 names to allowing only those and back. And I guess in some cases the normalization is not reversible, so you may lose some information, or there may be different representations, so you can't even change the normalization after you've created the data set and the file has been created in it.
If you change defaults, you're going to invalidate a lot of documentation that's out there. You'll have a lot of people creating data sets, volumes, and whatnot, not using the flags because the docs are now wrong.
So from my perspective, normalization doesn't matter much to me, but UTF-8 only does, particularly because NFS v4 is UTF-8 only. And so I already know that all of my clients are doing that, and it's really a matter of at which layer in the stack am I going to enforce that? Am I going to enforce that in NFSD, or am I going to enforce that in the file system? I'd rather enforce it in the file system because I still have local access on the server to those files, and I don't want to mistakenly create something that is wrong. And I know in the past, I think I've mainly remembered to do this now, but in the past I've certainly had issues where file systems were mistakenly not created with UTF-8 only equals on, and then suddenly I had to deal with some files whose names were not valid UTF-8. And what do you do? There are actually some ways to deal with that. We had some discussion in the Austin group actually about doing that for other POSIX stuff. If you could have a POSIX locale that was UTF-8 compatible, but didn't just error out every time you saw an invalid encoding. So there are ways around that by like re-encoding invalid octets that come in. But I don't, again, I think somebody said, that's not really ZFS's responsibility to do that. But I would certainly, I sort of feel like, I personally, I am not living, on my home systems in a UTF-8 world, but I still create all my file systems that way, because otherwise I'm just going to be horribly confused and sad and unable to list directories when I finally do actually manage to get my personal environment switched over.
I think detox would actually fix all your problems in that scenario.
Detox?
Detox. It's and it just goes through and cleans up anything that doesn't match what your file system says, or whatever you pass it, saying, hey, I want it UTF-8. I'm going to go flag and rename stuff as fix me, and you can go through and with that list, do any manual corrections, and you're not losing any data at that point.
Will Ascend allow you to at least get that data set with the correct properties, but with screwed up names? And you're shaking your head no.
To Michael G's point about defaults, I think that one came up recently with the xadder change, where just because of the order of the enum, with the new default being SA, when you ZFS get the property, it would say on. But all the documentation is like, on's the wrong value, you must set it to SA. And so you run ZFS set xadder equals SA, and you get it, and it says on. And so we just switched the order in the enum to actually display that, it is SA. But even to the point now, that means it doesn't necessarily look like it's set to on or what the inherited default would be. It is, looks like it was explicitly set to SA. I know we dealt with that a little bit when we changed the default of what on meant for compression from LZJB to LZ4, but it might be something we need to think a little bit more about of how the user interface and experience around changing the default and what followed that has on docs that told you, the old setting of on being wrong, where maybe all of that time that setting should have been saying dir. And then yes, dir is wrong, SA is right, but on is documented as being wrong previous to this version, and it creates a lot of interesting headaches.
So I have a nasty question about a particular case in German where there's the letter SZ, which used to not have an uppercase version until Unicode 5.1, which added it in 2008. So if I have this and set it to insensitive, so what happens with SZ? Historically, it has to set it to two uppercase S when doing the match. So how does the collation handle that? And if that changed, can you configure which Unicode version to use?
That I think would be specific to your operating system, and luckily is outside of ZFS's problem scope.
Any last thoughts before lunch?
So just getting back to the original question of what ZFS 3 should mean, when we went to ZFS 2, that's when we support a new platform with FreeBSD. And a lot of the things that we have on our list are things that I would think would go into like a 2.5, 2.6. So I think 3 for me would be either user, like a fuse driver, or we somehow pull in the ZFS on OS 10, or we have a new platform. That's just my 2 cents.
Brian, you should have the last word on this discussion. Please take this opportunity.
Yeah, I'd second that. That's kind of more in the spirit of a breaking change, right? Pulling in a new platform. It's maybe the time when we'd have to restructure things a little bit more internally. And there are major headline features which fit with a major release. So, the fuse port would be great. We got Windows, Lumos support, right? Those could come into potentially into 3.0. Or some other major headline features, things like AnyRate or whatever, that are maybe a little more disruptive. But yeah, I'd think about it in that context. Plus, anything we can come up with where we do want to remove functionality, this would be a great time to do it. I don't know that I have anything on that list necessarily. We've tried really hard over the years to have backwards compatibility, and that's a real strength, that you can roll back and you can have that kind of compatibility. So I guess I'd just leave it at that.
Yeah, like the fact that you can ZFS send a snapshot back to a pool running like V18 and it'll work.
Yeah.
Just paying attention to one of the challenges for ZFS now, I was told about how, because it's such an old file system, a lot of the optimization was built around dealing with seek times and things like that on old disks, and now we have SSDs. So while, getting rid of all of that may not be an idea for 3.0, possibly starting to identify and possibly, demote those features over time could be something that a major release could be doing.
To that point, I had a great chat with Rob Norris, who just did a science project, ripped out the queues and said, what does all-flash ZFS look like? And he just pushed the bottleneck elsewhere and went back to the drawing board. But that's a discussion, I believe, that, thank you for that reminder. That's exactly it. I have one super quick clarification. Is the hypothetical user space ZFS in fact Fuse or something like it? Because a lot of people think of Fuse as this super early on, super slow Linux ZFS that you never want to hear about again. Is there a new name we could use? I just throw out Zuse, but
Something like it, right?
Something like it.
It could be Fuse, but whatever. So you can get a full built-in user space with, the functionality we talked about with, the normal ZFS experience. And I think the idea of making it available as like a standard library interface too would be really good. So I would think both of those two would be major features. Fuse is one way to go about it. I'm sure there's others.
You said standard library. Are we talking libZFS or something else?
So not libZFS, but it'd be a bit more like
Maybe libZFS core, probably.
Oh, yeah, and that's an ongoing discussion where
But some stable interface. It could be libZFS.
Some stable interface.
Well, like the libz pool that we have now can actually take ioctls and so on, right? It's what's used in the test suite to run ZFS and user space and things like ztest. So it would potentially allow an application to use the internals of ZFS, and in the example, the application would directly open the disk and do the pool, and the pool wouldn't be visible to the rest of the system. It would only be inside the application. But it would then get all the semantics of ZFS, the checksums and the compression, all that inside the application, and it could be writing to a whole disk or even just a file, and it's just the file is formatted ZFS effectively.
Maybe you can
And so, for example, a hypervisor could, treat each disk as its own Z pool or something if it wanted to.
Yeah, that interface exists today. It's just that we've never promised any stability on it, right? It's our internal interface. We change it when we need to, right? If you wanted to build applications against it, you'd have to make up stronger promises about that interface and it not changing.
And that gets into the whole conversation about libZFS that's somewhere else on the schedule.
Right. Who wants to describe for one of Rob's quiz? A great presentation at HBSDCon. It's his quiz, user-facing, Control-C, testing,
it's just a
CFS.
lightweight hypervisor thing? I don't actually know.
All right, let's investigate. Check out Rob Norris' quiz. It's quite cool. Despair Labs. Well, have a great lunch, everybody. Thank you.
Recording stopped.
going with the flow, I'm going, now that a bunch of people have rolled in, I'm going to jump to something that just didn't quite fit this morning. It was informal, we dove right in. But without further ado, let's take this opportunity to thank the dickens out of our sponsors because they've been fantastic. So have any of the Delphix Perforce folks rolled in, or will they all be tomorrow? They're tomorrow. Well, thank you, Delphix and Perforce. You rock. You've made this very much possible and given us a surplus. You are awesome, and your years of support are profoundly appreciated. Thank you, AWS. Have any of the AWS Nieki arrived? Tomorrow. Welcome. Thank you, AWS. You rock. First time, I believe, supporting recently, and platinum sponsorship. Awesome, awesome, awesome. Thank you, gold sponsors. I know some of you are in the house. We've got Stu with Digital Glue. The OS Nexus folks, I believe, might be in Vancouver or hopefully here tomorrow. Thank you, OS Nexus. TrueNAS folks, just stand up. We've got, boom, we've got Andrew, we've got Mav, we've got Chris, we've got alumni, we've got all kinds of folks. Thank you. Thank you, silver sponsor Clara. We've got at least Alan, which is a significant part, plus your team. Go ahead. We've got Paul, and I'm sure a lot of us have just bumped into Clara in various ways. Thank you so, so much. And a unique one, Capital Auto Group, which is a local client of mine who has helped with logistics and other things. And we've got Levi here from Clara. Capital Auto Group. No, Clara. But I'm a bad joke. Thank you, Capital. Thank you, Levi. So I want to get that out there. So that said, we had a great discussion, and I want to pick up where we left off. This is your event, not mine, and I'm happy to be an organizer and moderator and secretary. And you tell me if I'm any good at it. But if you want that format to change, so be it. I'm happy to take notes. Shall I continue to do that and just kind of bang it out as we go? And it's, at least it's all public, and we'll take it from there. So if I hear a volunteer to take over this role, raise your hand. But if not, I'm happy to, because seriously, you are the most awesome people to work with. And again, for those on the stream and future recordings, this room is full of engineers and sysadmins. And that's it. The catering people walked 30 feet in, dropped off the food, and left. They're really nice people, but I doubt if they've heard of OpenZFS. And having an event where literally everybody is part of it, where a storage architect is running the kitchen, thank you, Stu, where Patrick, a consultant and small business operator who will have a say in this, one of these upcoming sessions, is running AV, and having all of you help out with things like taking out the trash, which is both physical and literal. Thank you so, so much, because this is heaven, and y'all brilliant. Picking up where we left off, Chris, do you have a mic in front of you just for a sec? Okay, so there were some narratives over lunch that I just want to get documented. And one we left off with was this test suite currently does this thing in user space. Is there a single phrase I can just throw in there? It does something. Maybe not. Okay, but that said, let's do some context. We discussed user space ZFS, OpenZFS I'll say, and then this notion of real-time replication has come up for years and years. A lot like package base and FreeBSD, where it's been this neat idea for a very, very long time, and only recently has someone said, let's rip off that bandage and do it, and make some hard decisions, and some hard fixes, etc. And following that metaphor, real-time replication has been coming up. In my decade of TrueNAS support, everyone wanted a cluster, or they thought they did. And they had the budget for 1.5 machines. And I'm like, so you have a quorum of what? And they're like, oh, what is a cluster? But I know I want it, and my boss wants it, because once you have a cluster, you don't have to worry anymore, right? It's like, well, no. It's a bit like a puppy or an Italian sports car where there's a lot of care and feeding. The setup can be a lot longer. And feel free to just search the recovery procedures for the clusters and CEFs and all those options. And people get really quiet really quickly, where in ZFS land, a disk replacement is a very well documented, very predictable, very stable part of the experience. And we'd like to see that consistent experience across the board, would we not? Such that, correct me if I'm wrong, I overheard that user space ZFS, OpenZFS, might be the building block for a easier to build, easier to maintain, easier to get adopted real-time replication. Chris Moore, do you want to repeat your narrative on that?
There was just a bunch of us talking here about that. It may help development efforts, if anything. It's just easier to get set up and test.
Use cases.
I would defer.
I trust you have a use case or two up your sleeve with your constituent base.
I would defer to the experts who would discuss how difficult it is to go and do real-time replication. But we have use cases. You mentioned it. Customers say we want a cluster until they actually learn what a cluster is, and then they're like, oh, we don't want that, but we want these properties of a cluster. Right? At a small scale, we're usually talking 3 to 5 systems. We're not talking hundreds. We're talking single digits, low single digits. Is that something we could potentially find a way to grow in ZFS? I mean, you want a sexy marketing feature, there's one.
I see Rob's lit up and is shaking his head. Does he have something to say?
Yes, please. Rob, it's good to see you. Cheers. We don't hear Rob. Patrick? We don't hear Rob from Zoom. Yep. Hey. Go ahead, Rob. Do you hear us?
Oh, I hear you.
We can now hear you. Welcome.
Oh, that's great.
We can hear you now.
Well,
Go ahead.
thanks. Good afternoon, everyone. Yeah, I was just saying I'm going to be a little bit shaky because I've been awake about 15 minutes. So, I've loaded up on coffee. Yes, user space OpenZFS is like my #1 personal want and has been for a while, and I continue to work on the sides, and there's about 20 use cases. So, but they're on replication specifically. Yes, building it in user space is, I mean, I would build everything in user space, but also I think it's possible to do. It's been built before for, databases mostly, which we are a database, so that's fine. And it's very doable. There are some problems to solve, but you get a lot once you can start the two. It doesn't have to be a cluster like a quorum kind of thing. You can even do, just having active replication between a peer. Just, one is a primary and one is the, like the backup, but you are keeping them in lockstep. And you have whether you have a floating IP or whatever you have, a load balancer, some kind of failover protocol. Yeah, that's basically what I was nodding at. I've thought about it a lot. It's hard, but tractable. And user space is a good place for it because, you don't actually have to have the, all you need is the disks and a way to get the data in there. You don't actually need the kernel for any of this stuff. In fact, you wouldn't want to because you want a lot more stuff around control, around visibility into what's happening. You want logs for that sort of thing. You want to be able to, you want to be able to do lots of stuff. So I realize how vague that is because Alan saw me nodding, and this is basically my big noisy nod. We can do that.
Do we have prior art from some science project that one of you or your colleagues did a number of years ago?
Me?
Any of you?
Oh. Oh, well, not specifically, but not specifically to OpenZFS, but I wrote and maintained for many, many years a multi-master replication for MySQL since version MySQL 4, I think it was when we started it. And yeah, it didn't have the ability to do that out of the box till 8.26, I think. So that was only a few years ago. Yeah, and I mean, like, it sucks. It sucks to operate. It's like, you know, now you have a cluster and you know, now you have a bunch of computers, and so you get a bunch of things that can break. But yeah, I've done it fine. And then a friend of mine now works at MongoDB on their replication engine, and from my conversations with him, it is basically the same. And then when I, like, conceptually, and then when I think about the moving parts we have in OpenZFS, it seems pretty much the same there too, which is mostly, we already have the replication stream, and I don't know how, exactly how fit for purpose it is right there, but pretty much you're just adding a negotiation thing on the top. It's the, you know, the two sides talk to each other, they figure out that, you know, they do feature negotiation, they do whatever else, but they actually say, okay, well, I've got this thing, where are you up to? I'm up to here, could you replay me everything between, you know, 27 and 38? Go.
Yeah, I think the difficult part there is, well, not difficult, but effectively, unlike normal asynchronous replication, the remote side needs to know the transaction group numbers of the things it's receiving.
Yeah.
So with normal replication, you don't care. You have the snapshots as the kind of arbiter there. But if you're doing real time, the destination needs to know which transactions it has received to be able to say, you know, I need everything since this transaction group. And the source can easily do that without necessarily needing a snapshot. It's basically the same thing as a bookmark. But unlike current replication, the destination would need to keep track of what transactions it has seen and know which ones it hasn't seen yet.
Yeah, I figure if you wanted, doing it pool-wide, because we sort of take the easy option, if we did it as a pool-wide kind of thing, then you could probably grow the replication stream a little bit to, or the negotiation to basically say, you know, like keep the transactions in lockstep. So that would be a little invasive in the code. But, you know, like I imagine some people would be building it that way. But if you wanted to keep it data set level, which would mean wanting to have your receiver is also be able to have like active data sets, then I guess you need to maintain a, like a, you know, a mapping or a notion of like, you know, this is my peer, and these are the TXG ranges in between, or this is how, I'm not sure exactly. But like I say, I mean, a layer of indirection, every computing solve, but it still seems possible. Like there are difficulties there, but I mean, it's a fundamentally different kind of system. I wouldn't be trying to remove the existing replication. To me, it would be
well, no, I think there's
possibly an add-on or possibly a different thing.
Well, and to your point there, I think there's an opportunity for a hybrid model where certain parts of it are synchronous. The new things like, you know, the other node needs to know that you're changing this file and don't let somebody read it until you actually have the data. But some of that data transfer maybe still ends up almost asynchronous. And so then you end up with a hybrid model where certain things are synchronous and so other things are more asynchronous, you know, with an f-sync boundary or something in between to kind of give everybody the right control.
So, Alan, you're bringing up right semantics.
Sorry, can
I think are actually, we're kind of getting, we've blown past them, and like they're not sort of described up here. Is there anything about the right semantics, or say the read from secondary semantics, that you care about, or would you feel comfortable like building this and seeing how it ends up working and then
Well,
just
I
saying
guess,
those
yeah.
are the semantics.
I think some of it is, for example, when we know that a write has happened on the other side, but we don't have the data yet, especially for this hybrid, partly synchronous and partly asynchronous part, we wouldn't want to tell a user who tries to read it that, that file doesn't exist, because we know that that file is in the process of being created. And maybe we are literally just being like, well, we're just going to pause here and wait for the data to show up and then allow you to open the file and read it, kind of thing. So it's just, that read has really high latency, but does have the right POSIX semantics of somebody called write and it returns success. So when you call open, you won't get eno ent.
We should just recognize that there is a gulf between like real-time primary secondary replication where the secondary is just hot and can be failed over to, but only one peer or one node is expected to be actually making changes, versus an actual like cluster file system, like a multi-master, multi-primary kind of model. And we should be clear about what we're targeting. I mean, I know we're just talking.
Yeah, like that's a good point. The difference between
they
active
are quite
passive
different
and active
things.
read versus.
And yeah, and maybe Chris can speak more to this, but I suspect there is probably some amount of demand for just like a more up-to-date replication kind of, or Daniel, I see there, maybe has some idea. Just would a live, but like up to the second kind of live replication be interesting? Because I imagine that's useful on its own.
That sounds great to me. I think, yeah. I mean, if I could get more real time between, primary, secondary, so twins basically. So what I'm doing now is I just, whichever one's not read only is the primary, and then I just have two replication jobs constantly pointing at each other. So when the read-only property stops on, goes on one and off on the other, then we just check the written property and replicate the other way. So if I could skip that sort of silliness and just whichever one's primary is streaming to the secondary. That's pretty good. I mean, that's whatever. It's 75% of the way toward what people want from a cluster, I think, in a lot of ways, at least on that level.
Yeah, if I could chime in real quick.
I think we
there's two use cases. Again, the DR scenario,
right.
A lot of folks want that. That's great. A kind of an up-to-date real-time DR is fantastic. But then there's also the branch office scenario we see a lot, which is I have folks in Los Angeles, I have folks in Texas, and then the data center somewhere in between. And I'd like all of the three sites to be active in the sense of they're each serving reads and writes and all that good stuff.
Right, and that's approximately 5,000 times more difficult, right?
It absolutely is.
Yeah.
But that's that's what the very next ask will be.
Mm-hmm.
But that said,
So
there are architectural
think we
questions to not preclude
skipped
the other. Go ahead, Jan.
First part, which is, are we talking about a shared disk or shared nothing architecture? But so far, all the discussion implied it's shared nothing.
Well,
And
it's shared namespace, I guess, really. But yeah, the
shared
disks would be
namespace,
separate
but not shared disks.
between the nodes. This is not.
So you don't have the disks
SAS
via
multiple.
iSCSI and serve reads from the same disks, right?
Right, yeah, these are completely independent pools that are basically real-time
Then
clustering.
the other is, would it be a synchronous replication, as in don't every async write just happens and every sync write gets delayed until it's acknowledged by all followers?
Well,
or would this be a continuous asynchronous replication which stays as close to the leader as performance allows?
I'm pretty sure Chris's version is the full synchronous, right?
Correct.
Yeah.
Yeah. It can be, lots of cluster systems will have like different modes for this. How am I willing to serve stale reads from local which as a file system, I can't really imagine why I would want that.
Right,
but
I think like the DRDB
but
people
yeah.
had a version where it's like synchronous, but as soon as it's in RAM on the other node, it's okay. And I think, what's the geom, HAS?
Geom Gate does the same. It
HAS
defaults to what
specifically.
they call memsync.
Yeah, and that's, I think, generally been found to not ever be what people want, even though they think it's what they want. Because it still has the ability to end up, the data doesn't actually get written to the disk. And so I don't think a lot of those other modes are nearly as interesting as just, properly having the, either you need the full synchronous version like Chris is looking for, or, as close as you can get of kind of a continuous replication rather than an actual cluster is good enough.
Especially for the branch office use case, I can see the continuous replication being quite close to what people want, because they either have too much latency or not enough bandwidth to guarantee that every burst can be synchronously replicated.
Yeah, the problem there is without some synchronousness, you end up with a conflict where the file's been modified on both sides, and then there's no way to solve
I would
that.
assume that the followers are read-only while they're following, right?
Well, not in the branch office scenario, no. All three nodes have to be able to, legitimately do things, and all of them are actively changing the file system, so they need coordination.
The writes are not proxied through the leader.
Well, one option is the proxy to the leader, another option is some kind of distributed locking, or, that's kind of to be settled, but yeah, all of those are hard, so we kind of will have to see which one it makes the most sense in this context.
Yeah, there is a, this is all, there is plenty of literature on this. There is probably a question of whether, like distributed file systems, how far down that road we actually want to go, and are we better to I don't even know what I'm saying, but like provide primitives to some degree. Like maybe we want to make it, Luster is already a distributed file system that can have ZFS under it. Maybe looking at that and having a secondary project that is a lighter version of that, or something different. I don't actually know how it works, so it doesn't matter.
I think Chris's goal in this case is to target a scale of 3 to 5 ZFS nodes, whereas Luster is, racks and racks of machines.
Yeah, but maybe there's there's some common primitives that would be better for ZFS to incorporate for another project hand waving away to build on top of, rather than saying, oh, we're a distributed file system now. I don't know. I haven't thought through that at all. I'm very wary of saying, yes, we're going to do, the full fat, network-wide quorum-friendly cluster file system, because then we'll just die.
For your grandchildren to enjoy.
I hope.
But, that does raise a question that Rob kind of touched on that maybe goes to Chris of, is this always pool-wide, or are we opting certain data sets into the replication and having some stuff that is only local?
Tough call. I think obviously pool-wide is the easy solution. I would probably start there. Sure, some people will ask and say, yeah, but I want a data set that isn't synchronously being replicated because I want performance locally.
But that's a separate pool, will go away.
Yeah, separate pool will go away.
I will. Sorry, I've just interrupted someone.
No, go ahead,
If
Rob.
it's pool-wide, you're effectively committing people to having at least 2 pools in their systems if they're booting off ZFS.
Well, I don't think you're going to boot off the distributed system, hopefully.
Well, yeah.
You need a boot file system, so if
Well,
that's
that could
not
be a different
replicated
ZFS
as
pool,
well.
though, right? That could be
Yes, so everyone
non-distributed.
needs 2 pools if it's pool-wide.
Sure.
But on
I
that
think
point,
most large-scale file servers have a separate boot pool, I would hope.
One would
You
hope.
would hope so.
Our
Yeah.
constituents understand database level snapshots that get replicated, such that flipping the model to pool might just be a bit of a challenge, but
I will say there are things that even if we didn't do, like stepping aside, there are still reasons to have some understanding of pool-wide or at least multiple data set replication. We have things that, and also communication between peers, because we have things that we store that we can't easily replicate right now. We can't replicate like the block cloning table. We don't replicate the encryption route, which has come up recently on the issue tracker. We don't replicate it, but if we're replicating a single data set that has an encryption route somewhere else, and then you change the key, that doesn't get replicated because it's stored in a different place, and so you can end up with a data set on the remote that you can't unlock because the keys, the wrapping keys were changed, and it's a little surprising because you don't quite see it. It's a minor bug, but minor. It's solvable, but our replication is very much currently around the idea there is only a single data set and there's only what's on the source, and we have no way for the two ends to communicate, and we have no way to express really like multiple data sets or dependent objects in another part, like in the MOS or whatever. And so there may be some things that we can build to let us replicate those kind of things, so let us express those dependencies and those sort of things that are also first steps that we will need anyway for a much more comprehensive sort of live two-way replication. No, words. We need a word for this.
While we're thinking of words, I'm trying to imagine what building a data center on this would look like. And I'm wondering what you imagine happens when I unplug the rack that the primary's on. What do I do next?
In a cluster, there maybe isn't the concept of a primary. They're all just peers. And so,
I'm sorry.
If you're talking a cluster file system versus a cluster of servers, so this presents it. That's part of the language is figuring that out too.
Okay.
So basically, if every node in this cluster has a full copy of the file system, then it, even if you're down to just one machine, it can continue to operate. Although maybe it doesn't acknowledge, it can't fsync any write until it can get some other node to acknowledge, so that you don't end up with split brain. But yeah, there are different use cases. But like, if this is backing a hypervisor and different VMs are, kind of using different nodes as their primary, they can work without having to spend a lot of time communicating with each other, so that the data is replicated to, your 3 different racks, but you have some kind of idea of data locality where, you're still going to be able to very quickly read all the data, because most of the data you read is going to be data you wrote to this node, and you don't have to wait for the replication as much. But I would say in that case, if you unplug one of the nodes, then everything should still be fine as long as you have quorum, but we also have to decide what quorum means, and if it is only a 2-machine cluster, how much do we allow a node to continue and then catch the other node up when it comes back, versus how do we ensure that the other node is actually dead and not just network partitioned, and we create terrible split brain that will be hard to recover from.
So I think this is also, as we sort of touched on the same question yesterday, of like how much does it make sense for ZFS to do? So this may be a thing where ZFS can provide an underlying replication mechanism, but if you want to have a quorum system, or if you want to have, automatic, leader follower failover, you need to bolt on some extra mechanism that knows what you're trying to implement and does that, rather than trying to expect ZFS to do it.
Garrett, that is basically saying that certain kinds of replication are inherently really stupid things to try. Just fine. But like master, let's say you've got a 3-node cluster. You have VMs that you're writing to. I'm not clear how we're talking to it, but let's say that you're running the VMs on the physical machines, because I don't want to add more networks in here. But you've got some VMs running on these 3 different machines, each of which has a big Z pool, and they're replicating between them. And Alan just described write once, read. No, it was like read.
No, I was just saying that,
like you're accepting a write
development.
commit to one, accepting async replication to the rest whenever. You're not doing a write block.
Well, in general, we were assuming that we would do a write block. It's just that you wouldn't have to wait for that block in order to read back, because you have the acknowledged copy locally. Like basically, one VM is going to be hot
Right,
on
so
the node it's writing to.
That's a
so the
read
reads
form
will
of
be
one
fast.
in normal, like, distributed database stuff. But like part of the thing about distributed database conversations is all your clients are remote. So this, like, you don't deal with fsync. Nobody needs this many layers of abstraction for normal database clusters, especially since like DynamoDB. So, agreed,
Yeah,
we
this
need
is-
a word for this, but
This is actually a challenge that file systems, like POSIX file systems, are going to have doing this transparently, because, if you're doing a fully clustered master thing, you can you build your sharding, your load distribution, your routing into the network, so none of the clients ever know. When I worked on IMAP servers, so this was Cyrus IMAP, and this was, we always had a single logical server to where a user's mailbox was assigned was 3 separate installations, 3 physically separate machines, one in each rack and another at another data center. And one was designated the primary at any given time, and it's replicating its changes out to the other 2. And then we do a network-based failover where if we lost a machine, if we lost a rack, if we needed to bring it down or whatever, we would basically disconnect everyone, force all the TCP connections closed, just send a reset, move the IP over to the other rack, make a config change on that, on what was the secondary, it becomes the primary. But the thing about IMAP is all the clients will reconnect, and then the first thing they will say is, I'm up to here, I'm up to this modification sequence number, what have you got for me? What's changed since then? And it would go, oh, here are all your new objects. Of course, all those new objects are immutable, because you don't write over an email. It actually had a way to, the client was an active participant in the replication, is a way of putting it. And we don't have that.
what you're describing is called
and we can't make that because the client.
Data
Sorry?
type. What you're describing is called conflict-free replicated data types, CRDTs.
Yes.
And the great thing about IMAP is, if you use Maildir, Bernstein just solved that by making no updates. But are definitely not imposing CRDTs on customers, which means that that whole class of database clustering is, you don't get the free stuff that it gives you. So we have to figure out like which of the triangle we want to fail on. Do we want to fail on availability? Do we want to fail on, I can't even remember the names anymore.
Availability,
Yeah, cap.
persistence, or cap. Consistency, availability, and partitioning.
I mean, and we can kind of redefine them so that we get a little bit more than two, but like.
Well, I think there's like 8 anyway, once to dig down. But yeah.
So basically, partition resistance is a requirement. Otherwise, the uptime of the cluster is strictly less than the one of a single node.
Consistency, I think, is what the other one was.
Yeah, consistency, availability, partition
So
tolerance,
here's an example
you can't
of
have
giving up consistency. You've got split brain on your 3-node. You have hypervisors running on each thing. They're replicating, but your one node thinks it's in an island, and it's still writing to itself. But somebody else on your pair is also writing to it because it thinks that it got promoted, and now it owns the write logs or primaries or whatever for that data set or whatever. It thinks it can write. So then what happens when you try and reunite? Well, that's split brain.
Right. Well, that's why I would say, you can't write if you can't talk to the majority of the other nodes. And so
Okay,
we don't
so
allow split brain
fail
to
on
happen.
majority.
Yeah.
Got it. Fail without majority.
Yeah, because there's no way to solve the split brain, so we need to try very, very hard not to ever get in that situation.
We cannot, I don't think we can ever have a generalized, conflict resolution, but rejoining the brains ourselves, so we have to avoid them, which means we have to.
You need a barrier there until the write is acknowledged by all nodes, because otherwise you get into the question of read consistency, which is an interesting one for a local file system like ZFS, because if someone else writes to a file on another node, when does the write, even if it's not f-sync, become visible?
I mean,
right,
that is.
Do you
part of the glitch
support
that we
stale
discovered over
reads?
lunch, where basically there might be, even in asynchronous write, there might be a synchronous component of, a write happened at this range of the file, and that gets pushed to the other nodes, even though the data hasn't arrived yet, because it will come asynchronously later. That node now has to block any attempt to read that range. Basically, we have a range lock saying, somebody's writing to this range right now, you can't read it until they're done.
But at that point, wouldn't it be both easier and more performant to funnel all the reads through an elected master, leader, whatever, and tell you, this is the consistent data you're reading. You may serve it from a local disk if you have it already.
Possibly, I don't know the latency.
Yes, you may be able to configure it that way, and there are clustered databases that have this notion. That is not necessarily, reading stale locally is going to perform better, but routing it through the office on the other side of the country is.
Jan, I think you're doing a thing that my brain really wants to keep doing, which is you're talking about reads like they're not local operations. ZFS doesn't provide a network read interface, right? Like, it's not S3. Reads happen at the VFS. So what does it mean, reading from another machine as your primary? Are we assuming NFS? No. So then what do we mean? Assuming we integrate S3, then we can have whole network semantics and define it to operate like Amazon promises it does, or like Minio in certain configurations. But ZFS per se, I keep talking myself in little circles because doing your reads through a primary when the primary is not yourself, that's not a statement that has meaning.
Of course not.
Okay, so then what do we want to do?
Basically,
we would have to create the equivalent of that kind of meaningless statement by making sure that the writes are synchronous to the degree that you get the equivalent of that. So basically, writes do not need a quorum, but they need a consensus of all still live nodes. Because then you can just read like a normal local file system, and it would be the writes which pay the replication cost.
Yeah, I don't think it would work quite like that. Like, again, the idea is that once, as a write happens, whether it's asynchronous or not, the other nodes have to acknowledge that first, and then once that write is there, we just basically, effectively, the writer has a range lock on it on the distant nodes, so that nobody can read that block until that node has the new content, and that releases the lock. And this way, if you attempt to read something after somebody wrote it on the other node, you just end up blocked until that read actually arrives asynchronously or synchronously or whatever to the node. And that way you always get the consistency between all the nodes, right? If somebody wrote and then somebody tried to read, they won't get stale data. They will get the newest version, even if they have to wait for it.
Alan, are you saying that it would be okay for me to have two different nodes with write locks on different regions of the same QCOW2 disk image that I store? Because, I mean, that is,
but like,
that's one definition of consistent, but...
Yes, but you wouldn't run, like, you wouldn't be having the same VM running on two different nodes. You would run into other problems there.
I hear what you're saying, but I have had customers.
Right. I can't solve that one. But this is more that, less in like the VM case, but we're looking at, Chris's main example is this remote office case, right? Where there's a video editing shop and they've got editors looking at it from both sides. When an editor in Los Angeles saves changes, and then the producer in New York wants to view it, they need to see the edited version, not some mishmash of the local cache that is out of date and what the editor just saved.
Alan, we've talked a little bit about doing stuff with the intent log.
Yes, this is my idea of streaming the intent log and adding some new records like, hey, I've started writing to this file. You would stream that to the other node, it would see that, and then wait.
Yeah.
Eventually,
and so
sync somehow the async writes would arrive, and then
if
nobody was reading the file, we don't have to do anything extra. But if someone tries to read the file, we have to tell them, hey, wait until we actually have the bytes.
But then, and that it seems like then the receiver for that is the thing that ingests that stream is really kind of like. It's a bit like the replay, but it's really like conceptually a kind of another source of syscalls kind of thing. It's like So
or VFS operations or whatever it happens to be.
VFS operations, yeah.
You would enrich the semantics with the someone else has the latest copy of this message in the intent log. So any read of that range will then be blocked until the lock is released.
But if you go back to the example from New York to LA, is, okay, I'm blocking now for an hour and a half, depending on your network speed. Is that something that is acceptable, that however they're accessing it, whether it's through Samba or NFS or whatever, that, hey, there's a file here, it's not ready yet, now that has to know.
This would be on a lower granularity, so it would be the record size, so at most it'd be 16 megabytes at a time. you could have locks on a whole bunch of different 16
Right.
megabyte chunks, but they would get unlocked
as they progress
as they
through.
approach, yeah.
But also,
how is
in
that
general,
going to
though,
impact the
It's going to buffer really badly in New York. until
Right.
It's replicated.
Yeah.
But
It's
I mean,
got- yeah.
but the file system that is sharing that out has to understand that it's a file in progress, not a I'm done file all the way
Well,
through.
the file system it would just sort of show what it had. It would be the same as it being. It would be the same as two processes on the same machine reading and writing to the same file, and those reads and writes can be very high latency, like maybe seconds or whatever. So it's going to end up being what the application expects. If you have an application where one is writing to the file, one copy is writing to a file and one's reading from the same file, how is the reader dealing with seeing either side of the writes? It's just over a much longer period, potentially. But that seems like that's entirely an application level thing, because we don't know what you're doing
No, I think
at the
Stu
file
has a
system
point
level.
that it might be very useful to be able to give feedback to the application that that's why this is happening, or even like possibly some way to return E again or something to tell them like, yeah, this read is not, this is locked, it's going to take a long time before you can have this.
You're not going to do that. Wait.
Yeah. I mean, yes, it would be great. I don't know if we have the interface for that.
Yeah, and I don't know that, yeah, like, there's no POSIX thing to tell the application that, hey, it's going to be a while.
Yeah, I mean, if somebody's using Avid and they were waiting for a lock to unlock as part of that write, okay, now what happens?
Would readers block future writes for the same range? Let's say I have a file and it gets updated in place by the application, just overwritten the same file range over and over, faster than the replication bandwidth. Will the reader block forever, or will the reader
So the reader's going to be
block future
until,
writers
like,
until it has caught up for that read operation?
Right, so the reader's going to block for a specific transaction group. So once that one replicates, it'll unlock, they'll do it, and then the next transaction group would happen. Because the user needs to get the version that it should have been when they tried to read it.
What happens if
necessarily
the
the newest
write
version,
is
but just
split
what would have
between?
been there.
What happens if a write gets split across multiple transaction groups? Let's say I do a single write system call with a 10 gig file.
A write doesn't get split like that because that write, like you can write 10 megabytes or 10 gigabytes or whatever in a single call. It will still be split up and stored into multiple chunks. That is not one write as such.
Yeah, like ZFS on Linux has a tunable that controls, like, no matter what size you write, it only comes down to the VFS layer in chunks of a certain size. And I think the default is 1 or 16 megabytes, something like that. But in the end, it would be at where's like the record level in ZFS. And so each record either got written or didn't get written in a transaction group. And so, but it does raise an interesting question of if someone has a read lock when we're streaming the ZIL, how much should we let them block us up if they're, I don't know, holding the lock and being really slow reading it for some reason?
And just throw another bug in it, because that's what I do. Having a bandwidth limitation on how that sync can happen. I cannot use the entire bandwidth available.
Right, you want to QoS the replication.
Exactly. I'm doing it in rsync now. I need to be able to do that with this logic. So not to lose it, but that is something that would be a requirement for actual production use.
And I think that's why it's really important to separate the synchronous and asynchronous parts of this, so that you can prioritize that, the communication of that lock separately from the streaming of the data that would unlock things.
And by pool or by data set to say, hey, this one's replicated as fast as possible with a 90% priority. Everything else fits in that 10% as it goes through. And yes, I realize it just got really messy really quick.
Yeah, you just want two ponies.
Yep.
Two-headed pony.
So I do hate to point this out, but this is both a really hard problem and one that other people have solved, whether in research systems or in actual products. And so again, I want to say, is this a problem that ZFS specifically needs to solve?
Yeah, I was adjusting. I've never run NFS. I don't know enough about it, but so as an example, I was just thinking to what extent is this reinventing NFS? To what extent can we just, or something else, but to what extent can we just provide additional help so we can do replication stuff under the hood, and then we can provide hints, help to the thing that makes it available to clients to understand what's happening? That's a question. I genuinely don't know the answer.
So here's my probably misinformed take. Listening to Alan, it sounds like the semantics need to happen around not file rights, but around not addresses, but records. Yeah, records. Okay.
Records.
So
files aren't real.
Yeah, right. But not whole records, because it can be regions of files. So
Yeah, but it's always atomic at the record. So
it's always atomic at the record. Okay, that's good to know. So the issue for me is if it's sub-file, what's the advantage of this over doing ZFS on top of distributed block storage? So that can be DRBD, there's various options, but
basically the ability to have the same pool imported on 3 nodes instead of only 1. That's effectively what this would be, is the fact that you can read from more than one system. Like you can build ZFS on top of something like S3, and then if it crashes, be able to import the pool on another node and get it back up real quick. But that's not the same as actually being able to actually read from more than one node at a time.
Why would having DRBD to 3 nodes and then ZFS reading from those block devices not
you
provide
can't
that?
write in that way. Like ZFS doesn't allow the same pool to be imported on multiple systems like that.
And so, but user ZFS would.
Well, even kernel ZFS would if you have this Zillstream
if
thing.
you have one that is in write mode and 16 that are in read mode, you can't do that right now with the same storage.
Right, you can't even have a second ZFS in read mode because it would need to know every time something changed that it needs to invalidate its cache.
No, but exactly, and that's where if that capability is in user land, which I think
This is not specific to user land, it just might be a bit easier to do in user land, but none of this is dependent on user land.
But being able to say, hey, I've got, keep it really simple, I've got two hosts. One is read-write attached to my JBot. The other one has the exact same visibility to JBot. Everything maps the same, physically matched. If I could mount that other one read-only and have no cache until I get read requests, does that solve the problem?
Not the multi-office problem.
Right, no.
It solves some problems, and like we were looking at something like that, a lighter version where it was just, I'm about to do a controlled failover, so can I get the pool imported read-only on this other node and get a lot of the slow parts of an import done, and then coordinate just flipping over the right bit, and then this node's going away. But if you import a pool read-only, it doesn't start a bunch of threads, and there's other stuff you have to do, and there's a lot of assumptions that, like, even without the cache, just you have to actually reread what happened on the disk because things about the pool could have changed. Or even like what transaction group number you're at. You don't know how frequently the other node is changing the most recent transaction, and so you never know what transaction you're at.
Well, and the use case from that is a CDN. I've got a CDN that's getting content in, and I've got multiple nodes sitting everywhere around the world talking to it to be redistributed.
But do you need it to be that synchronous versus just using replication?
Again, maybe.
Possibly.
No, no, yeah.
Having operated a CDN and tried to use ZFS to replicate TrueNAS for their downloads, I know the complexity of that one. But yeah, what you're talking about of basically being able to have a read-only import of the pool on the second node, especially if they're maybe SAS multipath to like the same physical disks, has a whole set of advantages and a lot less of the complexity. It's just how much ZFS has to keep invalidating its in-memory representation of what the pool is because things keep changing on disk without it ever knowing about it.
Right, because I mean, what
for
we're
that,
doing right now, what we're
intent
doing
log
right now.
would have to change to log which ranges on the disk have changed, so that the followers could invalidate or update their cache of that region.
In this case, it's not so much about the data, it's literally like the structs in memory in the kernel of like, what transaction group number are we at? If somebody creates a data set and we've imported the pool, we don't know that that data set's there. Whereas if you were on, when you're on the main one, you happen to have seen the actor that created that data set. But if you're importing that same pool read-only on a node, you don't know that somebody went and created a data set behind your back. And you can't just like throw away and re-import the pool every transaction group to hope to notice those because that's a lot of overhead in it.
Right.
What do you have to do in the middle to get there?
So back to the earlier conversation that apparently this morning was cluster day because there are at least 3 different conversations going on about it. But real poor man's clustering is those 2 nodes talking to the same set of JBods, boot up, one imports the pool or pools, runs application, everything's fat, dumb, and happy. The other system is up running, it sees the drives, it doesn't do anything to them. You're down it, you bring up, you do the import, you start the application. That is acceptable for 99.9% of the customers out there. If we can help orchestrate that versus having to cluster anything, okay, now it's a minute outage. If we can get that to a 20-second outage.
We've deployed that concept hundreds of times.
Right. But that's the thing that we can, as a group, say, hey, this is the right way to do it, and as part of our documentation or whatever, here's a sample architecture to do it the right way.
Yeah,
and you really don't need 2-second outages.
Right. And we've been looking at adding things like, I forget what we called it, but a zpool command that would do some of the stuff that happens during an export early, like condense the space maps, finish reading all the dedupe logs and writing those out, and all the stuff so that, especially in the controlled failover rather than the unexpected failover, that we can get the amount of time it takes to export on the old node and import on the new node down to the minimum by having processed all the space map logs and all the dedupe logs and basically make everything as fast as possible. And then the thing we were just talking about of, can we kind of get a pre-import going on the other node so that we know where all the disks are, and we've figured out a lot of the stuff that isn't going to have changed during the couple of minutes between when we're starting a failover and when it's finalized, like pool config stuff, but we can't make any assumptions about the dataset config.
Does that make sense doing on a routine basis anyway? I mean, how heavy of a footprint is that to just do that once a minute?
The zpool condense command? I mean, like in general, most of the tasks are kind of doing that as the pool's idle and keeping it short. It's mostly kicking that off, just like in some of our customers' use cases, like, all right, if we're going to fail over, we're now saying, let's drain the load off of this node. And so during that time when they can't turn it off yet, but it's under less load, we can get as much prep work as possible done so that the failover can be as quick as possible to get that window from 60 seconds to 30 seconds or something. Yeah. But yeah, the goal is 2 seconds is too hard.
Yeah, staged export.
Yeah.
Type. Yeah.
And kind of pre-staged import.
Over a SAS fabric or a network fabric? Because
SAS.
And 99.9% users don't have SAS, do they? So I think we're talking about a few different things here, and we're at the hour mark.
Those JBods?
Yep.
I mean, he's got hundreds of.
He does. I don't doubt that.
I've got thousands of them. So I mean, it's.
So we're at the hour mark, and we might want to break, having just had lunch, such that I'm hearing us go from real-time continuous replication of data sets and snapshots as we know them up to the ultimate clustering file system on planet Earth that might take some time to get here. And then the HA with those with JBODs and how we can simply make that better for our users as we kind of continuously do already in various ways. But in the context of strictly user space OpenZFS and a 3.0 release, do we have like one concrete tangible goal we can just slam on there? And we have a remote question perhaps?
We do have a couple.
Okay, bring them on.
On the Slack, Alex Pinchuk wanted to point out there is a probably pretty divergent now user space OpenZFS fork at GitHub Mayadata-IO C store, and that they do have a synchronous replication library, which is libc store. So that is in there. And on Zoom, Edmund White was pointing out that dual head node shared JBOD works for most cases, providing a good reference architecture that can go a long way. How much time can be saved by draining a node like this?
So a lot of the time in an export in the past was freeing the memory, and we made that be able to be done asynchronously after the export. Especially, in the case where you're taking the node down to upgrade the operating system, spending a bunch of time waiting for it to free the memory when you're about to reboot is kind of a waste of time. So that's the asynchronous freeing of the memory in the background is in 2.4, maybe even 2.3. I don't remember how long ago it was, but it's in new releases. And then, with the zpool condense thing, you can get the space map logs and the dedupe logs and so on out of the way to make the next import that much faster. But most of the time it's going to be relatively short. One of the other things from my talk tomorrow of using the new larger label to have the complete pool config on every disk's label could mean that reassembling the pool during import can be faster as well, instead of having to search every disk and figure out, hey, we know there are 8 VDEVs, and this disk tells me about that VDEV, and keep looking until you find 8 VDEVs that all happen to have the same pool GUID. Instead being like, hey, I found a disk that's part of this pool, and I know about every disk now, can at least help us more quickly put them all together and have hints about where the disks are. Even if we have to fall back to searching when things aren't where we expect them to be because JBODs and so on. It could, again, every little bit that helps them get that amount of time down so that your SaaS, dual-headed SaaS system is a fast enough failover that you can convince people they don't need a cluster. But when you're doing the satellite office thing like Chris is talking about, it's not good enough.
Yeah, data replication versus failover replication.
Very different things.
Have we invented the TrueNAS hardware of a non-transparent bus and the synchronized slog and all those things that allowed you to have 2 controller nodes and 1 JBOD, and are we just trying to do that?
The non-transparent bridge for the slog is extra goody for that kind of system, for sure.
Okay. So let's do just some takeaways and take a break. Someone somewhere make a list of how we can further speed up the import of the pre-import of a pool that will be on perhaps other 2 nodes. I'm no longer hearing anything about continuous replication where, okay, how do we just set it and forget it, and we know these 2 systems stay in touch with maybe a higher level notion of reversing that process.
Continuous replication seems interesting at first, but then it's not that much better than the regular asynchronous replication, and it's not good enough for the use case where you actually need the full synchronous, like, this write, don't tell the application this write is done until it's on both nodes. And so it's this weird middle ground that maybe is not better enough and not good enough at the same time.
Fair enough.
And it can still be interesting, and it's a more reachable banana, but
Well, and you also have that a lot of the applications now do it themselves.
Yeah,
And
for sure.
Postgres is a hell of a lot more efficient than it was 5 years ago in doing its own cluster replication. I mean,
exactly.
that just works.
If it's a database, you want the database doing the replication on 3 independent Z pools, not trying to have all of that happen behind
Under the
Postgres' back.
covers. Right, yeah.
So in the context of OpenZFS release 3.0, beyond the user space, possible component, is there anything that really ties in there? And we have a remote question?
Well, this isn't a remote question, it's just, I keep saying this, the application always knows better about how to deal with its replication than the file system ever will. And there's nothing we can do to change that.
The way I've looked at it is you need to have smart writers who, so if you have CRDTs, what happens when you get a write conflict is it hands it back to the writer, and it's the writer's job to resolve the conflict. So you've got that in all sorts of different distributed databases. That's what you need. You can't do that with a POSIX file interface. So to support POSIX file interface, we cannot give the level of consistency that people expect from clusters.
Until you get to buckets.
Which is not POSIX, right? Exactly.
Exactly.
Yeah.
That's
Like
where it changes.
we do buckets. We can do that. Like there's lots of subsets. Write only. We can do that. But like, you want to be able to do arbitrary reads and writes from addresses within a file. You want to mmap against something? Good luck.
Okay, so that is indeed the perfect segue to a discussion of object storage. So let's take a break. See you in a few. Thank you so much. Dear Zoom, the voice of God is here, but that's, the voice of Rod is here. He had to take off earlier. Andrew, you have a mic. You can, just hit the push to talk if you want to join in. And Rob, I'm so glad you're with us because we have 2, possibly 3 topics I'd love to just pick your brain on. I hope you've all had a great break. It's good. Any requests? Put them on the board. I say we continue into, say, the whole notion of where we're at on channel programs and libzfs and libzfs core. We have some very key people within reach. Welcome back. But Rob, what's quiz? Can you tell the group what quiz is? What's quiz?
The whole presentation. It's basically, it is a VM. It's a tool I wrote to. The idea is to spin up a VM in a couple of seconds, and to act like if you're prototyping a programming in like a scripting language or whatever, you just you write the program and you run it and you see what happens and it crashes, or you just hit Control-C, or it spits out a whole bunch of stuff, or you want to test something and you spit out a whole bunch of output and then you pipe it into grep and that sort of thing, and you just do it on your laptop, and then because it's a process, when it dies, it's gone completely. I wanted that for ZFS development, because I don't have much hardware, and because iterating on a VM in a VirtualBox or whatever, or moving your code into a VM or crashing your own machine or all that sort of thing sucked. So I wrote a bunch of shell to build a very minimal Debian-based system and Linux kernel config, and then QEMU config that will spin up really quick in a few seconds. I can develop on my own machine with my own tools, and then install ZFS into it, and then I can boot it. It'll run a script that sets up a pool, does whatever it does, just on memory-backed file systems. Output goes to the hosts standard out, so that I can just, I can put kernel log lines directly into ZFS code, have it print out stuff, which I can then grep. And when this VM dies, it's gone. It's completely ephemeral. There's no leftover on disk bit. There is, the single image that is shared between each run. And so that's kind of the idea. So the idea is to kind of make kernel development feel like just local development on my laptop. That's the whole thing. I did a talk at BSDCan last year, 24, which is on YouTube, and if you ping me directly, I can send you some notes. It's github.com/robn/quiz if you want to look more. It's not a ZFS specific tool. I use it for ZFS development. It's got a couple of little helpers in there to help me with that, but it's really a sort of a kernel dev helper. That's what quiz is.
Cool. Any questions from the audience about quiz?
I
thought it was a great use of all those tools. Go ahead.
Well, how is it different from Vagrant with KVM back? At all? Just different scripts?
It's mostly just stripped down to be what I need. You could probably do it with that. The really fast boot time, the boot to shell effectively within 3 to 4 seconds was critical, because if I have to wait for something, I'll forget that it's there, and then I'll forget to come back to it. So that was the main thing for me. And then to disappear without a trace, so no real disk or disk image. But I mean, yeah, you can probably do it in lots of other places. Like I say, it's just shell. So
you're making me laugh because I just forgot that I started a Vagrant. So
yeah, right. Basically, it needs to be done before I get bored and change to another workspace and go and read something, because then I'll never come back. So that was the main driver.
So it's just like if your Ansible playbook takes 5 minutes instead of 5 seconds, your attention wanders away.
Yep.
Cool.
Yep. I'm
Thank you.
proudly ADHD, so yeah, I bounce around a lot, sometimes by force.
So it's an ADHD medication for file system development.
There you go.
Got it. Thank you. I've done, somewhat crudely, my at best attempt to summarize the discussion in this very room last year, which, correct me if I'm wrong, libzfs is a private library, full stop. libzfs core does a few things that a few people want, and libzfs.py satisfies some users, and you may actually want channel programs for what you're doing, but they don't do all the things. And here we are. I'd love to know if anyone's made progress on that since then, and Jan, who I believe is on the chat, has kindly identified the 4 to 6 files that one truly needs to depend on and massaged a makefile to make use of them for a private C application. And, well, as long as the rug doesn't get pulled out from under that, it should work just fine. But I do want to nuance it with something on the board, which is the notion of either a channel programs repo, or how'd you describe that? But does anyone have news to report from last year's discussion on this, or are we at the same crossroads of like, well, you can want nice things, but we're just kind of, we see it differently, or something, or write it yourself, no problem, and maintain it yourself, and off we go. So, Rob, you've been very helpful in describing the problem, and you've produced a lovely blog post on that. Let's bring that up. This is since the discussion last year. Labs, presentations, quiz, but despairlabs.com, and that was somewhat better. So, has anyone not seen this blog post? I thank you for capturing the state of affairs after the meeting last year. Rob, can you summarize this for the group, as I've taken my stab at it, but I am by no means a kernel developer?
So, the reason, we've been talking about this in the production user calls on and off through the year, and the reason is that, and this is what I said in the post, there is desire for programmatic access to ZFS and to ZFS control facilities. So, creating a data set, creating a snapshot, those kinds of things. Something sort of, I suppose, more structured than calling out to executing the ZFS program. And there's a long way we can go now. We have JSON output, so it's easier to disambiguate some things in the output, which is very nice. But there is still overheads in every syscall doesn't remember the previous one. So if you've got kind of a wider context, there's still issues where, if a step fails in between, then how do you get back to a consistent state? Or, so being able to say, I've got this whole set of changes that I want to make, go. And then this just reviews the options that we have, which is the things people try and reach for. So libzfs is the sort of internal library that underpins the zpool and ZFS tools, but it's very much, this is an internal utility library. This is not for general consumption. It should never be for general consumption. And I mean, and it has its own reasons. It has its own reasons for existing, but it has some quite high-level concepts in it, and so people are drawn to it because, like if you are doing you know, the raw ioctals and you want to do a particular task, like say, you know, a simple thing, I want to list all the data sets. You actually have to make multiple calls into the kernel, which means you have to make multiple calls, you have to know what you want to do, you have to know how to do those things. Some are simple, some are not, some have weird arguments, this sort of thing. So it is sort of, people are drawn to it because they're like, oh, I just want to say, you know, verb noun, or, you know, create data set, you know, destroy, pull, whatever. So then anyone looking might look towards libzfs core, which is kind of the blessed, you know, committed interface. This by design is each function is a wrapping around a single ioctal, which is, you know, and has a sort of a common interface with like arguments and responses through NV lists, which are basically, just think of it as a KV, they're basically JSON, but programmery, they're fine. This is nice that it exists, that it's a, you know, committed stable interface, but it's, you still have to know which moving parts you have to touch in which order, and you know, how to construct the arguments and all the rest of it. So it's like, it's fine. And it also, it hasn't been fully filled out, so we can't do everything that a person might want to do. That's just a matter of time. Like, we could fill out all those, could and should fill out all those pieces, just no one's done it yet, which isn't useful for people turning up wanting to do things. There is Python bindings, which I can't remember what their bindings to. I think their bindings to libzfs core.
Bindings to the full libzfs and the libzfs.h header acknowledge the existence of the Python bindings by telling to always keep them in sync in the C.
Oh, yeah. Okay, they're bindings to libzfs. Okay, it's the same. But either way, they'd be the same thing. And they're just used, we just ship with those because they're used for some of the internal tools like your arcstat and that kind of thing. And
so I guess I have
then,
a question.
Yeah.
So, yeah, obviously part of the problem comes from people want to consume libzfs because it has the richer interface. It's how, you know, if you do it the libzfs way, that's the same way that the ZFS command line tool works. The problem being that, you know, it's not a stable interface. It changes every time we change something in ZFS. I've been guilty of changing libzfs a couple of times myself. I do wonder if something akin to symbol versioning could solve this here. If we kept the version of the function from 2.3, and when we made a change to the function in 2.4, such that a program linking against libzfs could say, I expect the 2.3 interfaces, and is still able to work, and we solve the problem of, hey, my tool that was built for ZFS 2.3 doesn't work because I upgraded to 2.4 and the new libzfs doesn't line up. If libzfs contained the 2.3 and the 2.4 versions of the symbol and the linker took care of it, would that solve the problem, or is that just making the library a god-awful mess to maintain forever just to maybe solve that problem some of the time for some people?
It would, that would solve a problem. That would solve an ABI stability problem. I don't think that's the problem that people have necessarily. So one of the things with libzfs is it has a lot of stuff in there that is very much tailored to how the command line tools want to work. Like, it has stuff in there for, you know, capturing signals. It has a whole bunch of stuff around errors. It has its own concept of like, it has these pool handle, data set handle things where it tries to cache certain kinds of information so it doesn't have to round trip into the kernel. But it doesn't have, you know, a sort of a noun-verb kind of concept. So it's actually quite hard to use as an API, and I don't think that solves it. Okay, the problem...
Right, so what people want is a libzfs that, or well, a a library interface to ZFS that looks more like, you know, things I've envisioned before, where you have HTTP-based interface to get input to create data sets and snapshots, rather than, you know, doing exactly what libZFS does, which is just implement the common bits between the CLI, which, are not aligned to how people use it so much as how the command line is implemented, which is not, you know, I just want to be able to manage some data sets in my user space tool that's creating containers or whatever.
Exactly. So we want to manage those conceptual kind of ideas, I think. And I'll just, I see it, hand up there. Jan, I know you've done a bunch of work with it, but
as a
just
potential consumer of libZFS, I can say that people are willing to put up with the cumbersome API. It would be nice if the library was easier and more pleasant to use. What worries me more is that its error handling and memory management concepts are designed for one-shot command line tools, not for long-running daemons.
This is exactly the point.
What I think would be a sensible kind of best of both worlds compromise if the ZFS command line utility would gain a ZFS serve command, which would just read basically lines of ZFS commands, maybe JSON encoded, and then return the responses, so that you don't have to have libZFS with its internal unstable API and ABI in your process, but you also don't have to pay the startup cost of running the ZFS command for everything. Because if you need to invoke the ZFS command 10,000 times, that's just painfully slow for certain automations.
Yeah, the startup, that's not a thing I want. I know what you're getting at. The startup cost for me is not really the issue. It's
also the parsing.
Well, it's not
the
startup
parsing
cost.
and hopped replies.
They're not really. They're not really the thing. It's each call into the kernel doesn't really remember much about what came before it. So if you are doing a larger composite operation, it starts each one from scratch. And that's not really going to be helped by that in user space, but also that's still kind of a crappy interface. It's something we'd have to support, but it's very shelly. It's very sysadmin-y, and you know I got nothing against sysadmins, but with a programmer hat on, I want to come in. I want to grab a library that feels like the language I'm working in, has clear concepts that I kind of understand. I want to say, where is the class type, or where is the object for snapshot? Okay, great. Or where is the data set? Great. So I get a handle on my file system, and now I say, you know, set property, set property, set property, and I don't, you know, or whatever, and I don't have to think about, you know, it works and acts like my language.
And doesn't do things like go and get all the properties even though I didn't ask, just because I opened a handle.
Yeah, but maybe it can be smart. Like, there's lots we can do, but that's where I usually come to when I looked at libZFS. I was like, this is not for people, and should never be. Like there is always going to be a need for something like it for the command line tools. So like, we could reclaim the name, but yeah. So the other, just to round out the survey. So the last tool you kind of have left once you get to that point is channel programs, which is, for people who haven't seen it, this is a little bit of, you can run the command ZFS program to load a little Lua script into the kernel. We have a Lua interpreter in there, and that exposes a Lua API that can do certain operations, like creates snapshots and destroy things and whatever. Some of the nice parts about that is like it will do it all on a single transaction, which is not sometimes, but not always easy to arrange from inside from the ZFS tools. But also that API is not well fleshed out either. And you are limited by things like it has to run very, very quickly because otherwise it gets killed. Because you don't want to, have a program that runs forever or runs away and eats all the memory inside the kernel. So it's got some very strict limitations on it. It also just personally, I just feel unsettled having an entire Lua interpreter inside the kernel. So that's kind of some kind of summary of the blog post, which is just surveying what we have. And yeah, my sort of contention has been, however we do it, we need a programmatic interface that is good for programmers to use and also does all the job. And that's what I have a couple of prototypes of things like that. But maybe, depending on what people need, maybe it's better just at least at the start to fill out libzfs core, since we do say that's the thing. And then I have a whole bunch of opinions about about channel programs and about the ioctl interface and about a bunch of stuff, but I'll save those for the moment. That's what we got.
Are there libzfs core users and consumers in the room?
Yes.
Has it been the smashing success? Yes, sir. Let's welcome Andrew. How are you?
Well, we use libzfs pretty heavily. I do think a lot of people who want to use libzfs don't realize they can, I've had people ask before about a Samba module I wrote to get snapshots. We're using libzfs there, but when you're using Samba, you can actually just use the ZFS snapter to get snapshot information. And I think that's probably a lot better way for getting lists of snapshots if you don't want to have libzfs built or trying to write a tool against it. We have a Python module we've written around libzfs. If you want something more full-featured in ZFS proper, our Python module is written in using the Python C API, and we can provide something that's, in theory, I guess, probably depends on how Chris feels, but we can provide something that's more useful for people that just want to write a quick script to create snapshots and manage ZFS. I think Python's pretty easy for people, and we actually have documentation for it, which is useful. Just a thought of people actually interested in expanding the Python availability of libzfs.
It was described as a handshake agreement and with some certain uncertainty around it. Has that changed, or was that never true and that was just a myth, or how would you describe it?
Handshake agreement about what?
The API stability,
Well, if we're building a Python library and when people build ZFS, if we distribute it as part of ZFS, that would be simple. We just keep it in sync when you're making changes.
Yes, I think the point here is that if you have a higher level library interface, you can commit to that interface and still leave the actual, kernel user interface completely flexible and able to be broken as needed. Because the higher level interface is mostly not going to depend on those details of what exactly you're shoving into ioctl.
And when they are, because you're distributing the Python wrapper with libzfs, it'll be the one that matches. So it will have the new argument that got added that would break an application that was trying to directly use libzfs because the API changed. But as long as this abstracted interface is matched to the version of ZFS you're using because it's distributed with it, you wouldn't have that problem. It's kind of the same idea of, maybe overusing the term, but making libzfs a private library in FreeBSD means that it's only used by other tools that are part of FreeBSD, which know they will always be the same version as that version of libzfs. So, you know, when BECTL uses libzfs, the version of BECTL that would be incompatible with a different version of libzfs isn't going to be there, right? It's always going to be the version of BECTL that's compatible with the version of libzfs that shipped with the version of ZFS that shipped in FreeBSD. And when you upgrade, all of those will change atomically at once to the next version and they'll all work together. But, you know, with Delphix's appliance, when they were using libzfs directly from C, if every time, you know, we added an extra argument to a function, it blew up their entire appliance and they were like, can you not please? And so, yeah, if part of that is, you know, libzfs core getting bigger and being, you know, mostly just that thin wrapper around the ioctal, but handling that slight differences between, you know, we added an extra field to the struct or whatever. You know, most of the ioctals now, I think, are NV-less and are a little less persnickety about adding moving fields than when they were raw structs, but yeah, it really depends on the use case, and I think having something that's more like what the consumer wants would be useful, but I don't know that any two consumers end up wanting the same thing. But like enough people make appliances on top of ZFS that I think creating and managing data sets via library could be all the same in all those cases. It's just, I don't know that anybody's kind of written a specification that we could try to work against.
Historically,
the problem is that there is no library to build upon for someone wanting to write this nice high-level abstraction, because the only place where the necessary types are declared to even invoke the ioctals correctly without just copy and pasting it out of the OpenZFS repository is in libzfs, not libzfs core. For example, libzfs core, in my opinion, should not be used to do anything which should show up in the zpool history because it lacks the ability to append to the zpool history. So only even creating a snapshot, which is possible, you cannot log that to the zpool history through libzfs core right now. Because the types required to do that are in libzfs, not libzfs core, and there's no internal symbol for it either.
The way that the zpool history works is its own tire fire, and I would rather redo the way that works so that it just works with libzfs core, because there's no reason it shouldn't.
Yeah.
Because like right now, it takes the return value, sends it back to userland. It decides whether or not it is allowed to be logged in the kernel, and then the user requests to log it anyway, and the kernel can decide to override it based on whether or not it believed it was a failure. It's horrifying. We should just redo zpool history, and then libzfs core would be closer to parity for a first-class status.
And the boot environment control command BECTL in FreeBSD, for example, doesn't write to the pool history itself. You only get the history if you run zpool history dash, what is it, L or I?
I for internal.
Because, yeah, exactly, I. And because, yeah, the ZFS command and zpool command obviously just concatenate their command lines with spaces to a single string and append that to the history, which kind of makes sense, but for a higher level command, you probably want the equivalent ZFS command invocations in the pool history, so that it looks like as if you had done it by hand.
I think that would be confusing.
Or at the very least, you want the BECTL command to go in there with its command line. I assume it was overlooked when the command was written because the ZFS command has some logic out of the way to decide if this is something which goes into the history and then do it, the concatenation into a buffer, log that buffer to the pool history, and then do its normal work. So it's far away from where the actual commands are implemented. So I assume when the BECTL command was written, this was just overlooked because there was no example which was easy to find to learn from, which, yeah, that's what happens.
Or just I did a bad job mentoring my GSOC student.
And then I'm not placing blame with anyone here, just describing this.
As far as the committed versus non-committed kind of interface things back from like the Sundays and still in Illumos, you can absolutely depend a committed interface on non-committed stuff as long as you're making, what you're doing when you do that is you're making the commitment to update the committed interface to match the non-committed stuff it's depending on. So that's exactly what you're saying.
Yeah, but right now in FreeBSD, you're missing 6 files to even build against libzfs and 2 to build against libzfs core without having the kernel sources checked out. So FreeBSD installs the libzfs header and the libzfs core header, but you can't build against the shared library with the header because the headers included from the library headers are missing. Something like the AVL tree implementation. And some of the other headers are part of the Solaris personality and user space, which is a disgusting set of C macro programming hackery, which is why I understand that this should not be available for accidental inclusion. But also not installing them makes installing the library headers worthless. So it's an oversight that we even got into the state in FreeBSD, in my opinion. And just not installing the headers would make it strictly worse, in my opinion, even if it would then be ideologically pure. Putting the library somewhere in user include private OpenZFS would not be clean, but it would be safe enough and would improve the
But as a
state for users.
consumer of libzfs, do you ever actually need the AVL stuff? Like how much
Yes,
of this is
because
actually
it's
just header
part of
solution?
it gets
I guess it's used for
included
the
from the
list of
headers.
callbacks
You
and
can't
so on.
build against it otherwise. It just says missing symbol, whatever, or missing type, that and that.
Because it wasn't meant to be an interface you'd be using generically, but yeah.
I know that it wasn't intended to be used without those. But having the headers installed, but having them depend on headers which are not installed is obviously not intentional, I would say. This case was never really tested because you weren't supposed to make use of those headers, right? Because it's not a stable interface, it's an internal implementation detail of OpenZFS. But it's also the only interface you get if you want to programmatically talk to ZFS from user space without, for every single operation, forking and executing in new command every time.
So, yeah, look, I think at this point, like we all understand that what's there is not fit for many purposes. So, I guess what I'm thinking is we've been talking about this for, let's say a year, because it was at last year's summit, and for me it feels pretty much like there's not really probably a lot more to say. At this point it's just, the work has to be done. It's like, yes, we could flesh out an API further. I don't think there's any particular controversy. I mean, there's no libzfs absolutists in the room. It's not a one true way thing. It's just going to be someone has a tool in mind, someone writes the thing, and off we go. Like, is there a consensus that needs to be reached here? I'm not sure.
So if someone were to write a libzfs for humans wrapper and were to propose this for, please include this in your operating system distribution of ZFS so that we have a stable higher level interface which would probably look like the Python interface ported to C memory management. So callbacks with context pointers and so on. Would there be a willingness to accept this instead of, oh, we really should one day eventually in a far, far away re-architect libzfs.
Well, I don't think anyone is saying we really should far, far away do anything. I think it's simply like we more or less know what needs to happen, but it's time equals money. So it's like, I mean, I don't know. I don't feel like I lack clarity in this area. I know exactly what I want to build. I have a couple of prototypes on the bench that, you know, are only like 10%. So it would take me a long time to bring them anywhere, but it's just like, it's just got to be done now. At some point, I'll decide that I want to write my ZFS dashboard properly, and it won't use any of the libraries we ship with. It'll use code I wrote myself that hits the kernel, and it'll be great, but maybe that'll only happen in 5 years because I'm tired. I don't know, I'm trying to bring this, I would really like to bring this topic to, if not a conclusion, just some understanding that this is the next step. This is the thing we are stuck on.
So, I'm hearing two different, actually, I'm not hearing it. I'm barely following you guys. I'm having a hard time. But looking at your article, I'm seeing two main sort of destinations that are desired. One, you mention a whole bunch of, were they pull requests or feature requests or something? Oh yeah, 100 possible pull requests, all used to instruct OpenZFS to do things outside its normal storage operations. So, like, my first thought is like, how many of those do we kind of want to bless and give a man page or a, you know, paragraph in a man page, and just have a command line tool and make sure that they're idempotent enough that there's a chef plugin or a salt plugin or whatever, so operators can operate them safely. And they've got JSON interfaces and just like, it's boring. And then how much is, I need to be able to do lightweight prototyping with Lua and Python or some scripting language, and I don't know what I need, but I know I'm going to need more flexibility than a bucket of command line tools that have been thought through enough to get man pages. Is that sort of the two
I think that's
focuses?
a really good question. I think that's a good framing.
Okay.
Like, and I know, I mean, I'll let Jan speak to his own thing if he wants, but I know there it's kind of part of the, he's got a sort of, his system involves some amount of using the ZFS syscalls, the ZFS command line tools, and some amount of channel programs, and some of that is that the channel programs do effectively do multiple commands on a single transaction. Not quite, but that, and some is that channel programs do that, but they don't have access to everything, so he kind of has this interplay between, but I get the sense he's probably not really tied to one thing or another. So long, if you could just have one thing that would do a more performance thing or a more atomic thing or a more expressive thing just in one place. Sorry, go. Someone's yapping.
So atomicity would make it easier for me as the tool writer because I wouldn't have to assemble the intended semantics from multiple idempotent operations and wouldn't have to handle cleanup and so on. Because if I could go atomically within a writing ZFS channel program, do it all, that would be very convenient because the system would go from one target state atomically into the next, which would be ideal from the user experience in failure cases, but okay. I don't need that, I can automate around that. My use case is I want to specify how a jail should be assembled from a current ZFS dataset, which represents the whole jail, and then its individual mountable file systems are either long-living data volumes, which are not automated, upgraded, and so on, and read-only clones, which have to be made writable to create empty directories for mount points and then made read-only again, so that I can have immutable infrastructure automation for my jails. And I've prototyped that in shell with the clone updating mechanism implemented as a 3-stage pipeline of a shell script invoking a 500-line channel program. Okay, most of that is comments, but still, which then returns a list of operations to converge to the specified code, specified state. I gave a talk on that at your BSDCon, whoever is looking at, yeah. First day, first slot.
We're looking.
Hall D2. And we'll make this automation scripts available, but basically the structure is, there's a shell script, it takes the jail configuration, it runs a channel program, the channel program tells the shell script which list of shell functions to call, because the channel program API is rich enough to figure out what has to change. It's not rich enough to do the changes, because I can create new snapshots. Thanks to Rob's new feature, I can create new clones. I can't create new empty data sets from scratch, and I cannot modify non-user properties from the channel program, because the setProp function only works on user properties, because non-user properties potentially have side effects for some of them, and so none of them are usable. Like that. And because of that, this 3-stage pipeline approach is needed. With all of that, I have gotten the time to deploy a jail from just its jail configuration in a pool down to less than 800 milliseconds if you have a modern laptop.
Sounds like expanding channel programs might be the way to go for this. I still struggle to understand what we can't do with existing tools. Like PyLibZFS is pretty good, at least for everything that I've wanted to do. And you know, if it's missing stuff, then maybe we should work on existing tools and expand those.
So libZFS can do everything I need it to do, but it's kind of not made available, because basically as a user I get the impression as an operator I'm not supposed to code against that.
I was specifically referring to PyLibZFS.
Oh, okay. The reason is I would have to write my tooling in Python then, and I wanted to write my tooling in C.
I think
one final version of it.
Other thing worth noting is that, as users, when we talk about libZFS, we don't literally necessarily mean libZFS. We just mean some kind of programmatic API that we can use to interface with ZFS.
Right, and I think kind of to Rob's point earlier, having that interface have a little more contextual awareness and the ability to do an operation and then do a second operation, knowing what has changed from the first one, instead of, the way libZFS works now is because it's meant for all these one-shot commands. When you open a handle, it gets the properties and does some things and then closes. And so it means if you run 3 commands in a row, you get the properties of the whole pool 3 times. And it's a bunch of actuals you didn't need to be doing. And so having it be more context aware and able to kind of reuse information we just fetched instead of having to go get it again can be very useful. But yeah, I think this ends up looking like a different library or a large expansion to libZFS core, where you have this more kind kind of verb-based, or like we talked about a bit, maybe something that looks more webby, to just express what you want to get created, what data sets you want to create, what snapshots you want to create, how you want to change them, rather than libZFS is just kind of an implementation detail of the command line. But I think to Alex's point, like, without a very specific list of what it needs to be, it's kind of just, wouldn't it be nice and not a thing that we can build?
Are there consumers of ZFS who might be vendors or otherwise who could use a better non-Python, needs a better name, libZFS asterisk?
Well, I assume most of the ones that are building some kind of web interface, the Python one is fine. And that's why, like, they needed it, so they created it, and that's why it exists. And I think, to the point, like, if somebody has that strong of a need for a nicer interface to ZFS via library, then please build it, and we'll be glad to include it in the repo.
Is the plumbing there?
The people who need it will know what it needs to do better than we will.
Is the plumbing there for the Python one to be joined with a, bad example, Perl one, other languages, or is it just a tight integration of Python and ZFS?
Especially for FreeBSD, it would be nice
yeah,
to
that's,
have
can a
module
thousand
for
flowers bloom
Fluor.
based on that model?
I mean, you should be able to build one based on whatever your favorite language is. The issue's going to be supporting them, right? So we want to end up with one thing that we can actually reasonably support in the repo. And right now that's PyZFS, right? And then libZFS to some degree. Obviously there's some issues there, but yeah, we can't really provide, one for every language out there. But
And the sort of interface that's going to be idiomatic for different languages, it's going to look quite different. The one you build that's idiomatic for a Rust programmer is not going to look anything at all like what you build that's that's idiomatic for a Ruby programmer.
I mean, I think so long as you have good semantics around object life cycles and you have one scripting language using a swig binding, we can figure it out. I don't really want to maintain a swig Ruby wrapper again, but my life takes me where it takes me.
That.
But Jan's use case is in channels for the majority of it. Is that a correct statement of what we're lacking from it?
Do you want to be on mic? And Rob did, pre-context, add a feature or two that you can describe on the stream to meet some needs on channel programs where, I forget what it was.
I guess Stu's question is, what wouldn't be solved by adding more missing bits to channel programs, especially as Jan said, that it avoids the need for the consumer to have to do their own cleanup if a group of operations does not succeed somewhere in the middle, right? If you're doing 4 operations and the third one fails, you don't want to have to go and unwind the first 2 yourself. If you did it as a channel program, it either completed or it didn't.
My use case would be fully covered by a slightly richer channel program API.
So make a wish list of what channel program APIs you need, and maybe we can get there.
Setting properties and creating fresh file systems.
And I believe set properties during creation of new data sets, as I recall.
Doesn't really matter if
okay.
I can do it in the channel program, create with default and then set.
Did you get snapshot creation? That was one of the earliest operations of it.
Snapshot creation always existed.
Yeah, what did Rob add
That was one
for
of
you?
the initial features. Clone creation was recently added by Rob Norris.
Thank you, Rob.
Thank you for that.
Okay.
So,
any final closing thoughts, especially from other voices who have not chimed in this last hour? That said, yep.
Sorry. I do know that, early on you had mentioned the idea that a lot of people would have of having a very what is it, webby kind of interface for it. Yeah. Yeah, I think that a lot of people would very much like that, if that can be achieved somehow.
That's a security hole.
Yeah, but you can apply it
Yeah,
to
we don't
on
mean an actual web interface. We just mean an idiomatic interface that's like, I would like to do CRUD on data sets and snapshots and so on.
The JSON RPC service or what?
If you were to apply it on just like on a local Unix socket, and then okay, now I have a Unix socket, now I can put security stuff in front of it and give access to it that way, then it's now not ZFS's problem.
As long as that's auditable for who did what when, back to everything else.
Back to
that's my
rewriting
problem.
Drupal history.
Well, thank you, everyone. Let's just close it there and let the conversation continue in parallel elsewhere. Do we want to take a break, or do we want to press into a discussion of loosely an object type of data set that just might look like an S3 plumbing or otherwise? Show of hands for a break? Yeah, let's take a 5 to 10 minute break. Let's just keep it tight. Don't start those conversations. Just do what you got to do. Thank you. Rob, do we have you to thank for this new data set type bucket? A data set without data. So that would be an anti-set, anti-data set.
I wouldn't thank me yet.
Can we crank him up?
Afternoon.
I can't hear Rob. Okay, so I just want to first set the stage for this before we introduce it. We're probably streaming, aren't we, Patrick? Yep. Okay, cool. So the next and perhaps final official topic of the day is the notion of a data set type that is object-ish in some way by some definition, but fortunately, a few of those definitions have come up recently. So I would love to get some help here running through the history, which can be like 1 minute. And I know that perhaps Rob and Paul and others have both opinions and observations and project ideas that maybe didn't see the light of day. So I will kick it off, and you're welcome to join me up here and grab a remote mic, which hopefully is ready with Patrick and company. Great. Okay, so I looked it up. POSIX semantics arrived in '88. Joseph and company. Sorry about that.
Sorry, replication conversation never does.
Is it resumable?
You just gotta shoot the note in the head, it's fine.
I was going to shoot some, I know. So this discussion is about the notion of a new data set type that is object or bucket, representing modern object semantics and interfaces. And I looked it up. The POSIX semantics arrived in '88 when I got my license to drive. And in case you didn't know, apparently the DMU is an object store under the hood, and various folks have talked about interfacing it with, I suppose, Luster at various research labs interfaces with that, and maybe we'll hear about that. And I heard the statements that, well, we talked about an S3 interface at a previous developer summit, but I suppose it never went anywhere. And someone wrote this in, which I don't know if that is Jan or Rob, but I love the notion that a data set without data is perhaps even a source of humor and a clever name. But the terrible name I have been using for this, which will hopefully inspire you to set this straight once and for all, is OpenZFS 3, because it's a S3 interface, which was instantly confused with the notion of a release version 3.
I started doing OpenZFS little less at the end.
Oh, SSS or, okay, S3. Ooh, we could do the superscript, which will always screw up with a little tiny cubed. No, that'd be try. Okay. So, who wants to kick this off? Paul, can you give the history, non-NDA'd from Delphix and Company? Let's get him a microphone or stand right there. Let her rip.
I mean, so there's been discussions about this over the years. The idea of having the object store underlying ZFS exposed as, you know, a first-class primitive. I don't remember when and where all of these discussions happened. I think at least some of them were at previous developer summits. But the sort of the core issue is that most object stores expose like a HTTP interface with like, you know, post and get and it like delete, you know, all the standard things that you'd expect from an HTTP interface. And we don't want to have to implement one of those in the kernel. So there has to probably be something in user land that handles those requests and then sends them to the kernel somehow, and then the kernel deals with them in some way and sends something back down. And so that's sort of the most intuitive high-level architecture, but there's a lot of question marks inside that space that could use discussion and resolution.
So, couple of things. First, I want to point out, as like the token POSIX committee member in the room here, POSIX semantics were not revolutionary in 1988.
Oh, okay, thank you.
They were intended to standardize what had been in 7th edition Unix in 1978. and was basically like the common intersection of all the Unixes that existed in the late 1980s. But so I do not remember what it was or where I saw this, but there was actually a local file system implementation that had no naming, was just inodes. You would open a file by, you would use normal, Unix, POSIX, interfaces, but you would just open a number and that would give you the inode of that number. Or you would just open, and you would, if you wanted a new one, you would just, create with any random name you provided and it would just give you a new one. And you would then have to run stat to find out what its number was. So this is a thing that has existed in sort of other file systems in the past. And that, I think, is the right, kernel level abstraction to implement something like S3 on top of.
So that sounds a lot like FH Open, file handle open for some parts of the support daemons of NFS, to open something basically by file system ID, inode, and generation.
Except that FH Open, is basically only there to support what NFS does and allows you to open arbitrary files anywhere in the system, as opposed to what this thing that I'm describing did. Ooh, there's a bug in the room now, which, was just, on a file system. You would have, /foo/bar/12345 as, the reference to, object number 12345 in that file system. You couldn't use it to access, anything outside of, where you already had discretionary access to in the file system.
How did you keep track of things with that tool? With a whole separate metadata database for, file names and other fancy things? Piece of paper? Okay.
Yeah. I mean, I don't actually remember what the use case it was built for, but there's a bunch of things out there where basically you're actually, for example, implementing a distributed file system, and you want, give me an object store for the back end. And it was sort of built for that sort of application where there's something else that's providing the naming layer that, this particular server is not responsible for.
And with going fast forward from 1978 to now, one little bit of context I want to add is the whole notion of the Minio and possibly, GarageFS and other possible rug pulls, such that perhaps there is a world where OpenZFS provides a lot more plumbing than it currently does, and may 1,000 flowers bloom for all those HTTP interfaces to access what is a trustworthy, long-term trustworthy S3 interface. Let's see, more voices. Chris Moore, did you have a thought or two on supply and demand for S3 functionality?
It comes and goes. We see it on TrueNAS often enough. Usually it's a backing for Veeam kind of thing. So it's definitely not our most popular protocol, but we also don't love the games. We're playing with MinIO and others right now, and it'd be nice if ZFS could do this semi-natively, or at least provide better plumbing for it.
I guess part of the question becomes where you draw the line, to kind of Garrett's point. If we just have to provide the inodes, then it's fairly simple. If people want to be able to enumerate all the objects that exist there and have more metadata with them, is ZFS responsible for storing that, or are we, saying whatever thing is implementing the web stack on top is going to have its database somewhere else, and it deals with all of that? And how does that play with snapshots of an object data set?
and that was the key need from ZFS, was actually to be able to do that snapshot.
Yeah.
And with...
But like, how do you make the, if you're storing a database separately of, inode to metadata, you want that to have a consistent snapshot with the object.
Yes,
itself.
and the thought, and Rob and I talked about this a little bit, but having that as, sidecar-ish, whether it's a property value or whether it is, here is the name, here's the time it was actually done, and then as the snapshot rolls, those are maintained as a pair with the snapshot or any changes.
So again, I'm not an expert on the S3 protocol, so take everything I say with a grain of salt, but object versioning within S3 has been very important for the customers we do have on it, which is like per file snapshotting, all that good stuff.
Yeah, that's critical path.
Yeah.
In S3, I'm not going to say emulation because we want native.
But yeah, like the question there for object versioning is, does that look like BRT, or does that look more like, as Anil was talking about earlier, where every object is almost like a ZVol, where we can have its own snapshots? But I don't know that the kind of DSL layer of ZFS scales to having a separate object for that each contains one object.
So,
Whereas
we
if you use
talked
BRT,
about
you
this
can
in
clone
the-
an object and keep, the blocks the same, especially since in the way that S3 type things work, when you're versioning the object, you're getting a full write of the entire content of the object, not like a patch. And so if you just clone and then overwrite, we could use something like nopwrite to skip all the blocks that actually have the same checksum and didn't change. And BRT means that we're saving all the space that we can. So we're getting the clones or snapshot semantics, but without using a ZFS snapshot, just doing like a BRT clone of the object.
And honestly, for the customer base we're dealing with, they don't care about the amount of storage being leveraged. So they could be completely atomic and maintain state there as long as there are pointers to have something snapshotty way to feedback. That would be sufficient. And again, most of these people have no concept of what volume is anyway, because they're paying for it by the byte, not by the, hey, I'm allocating 2 petabytes for you.
I would expect that what you would want for sure is to have ZFS at least have a basic understanding of what the object is, and to keep track of that, because I don't see how you would get those kind of stability semantics and snapshot semantics if you're just handing back the inode. I think that would get very hairy.
In this case, it's just, imagine the current ZFS dataset, a file system, but with no directories. You just open a file by its inode instead of going through a bunch of paths to get to the name.
Yeah, but I'm saying
But
that
like the object would still have optional properties, like it would know how big it is and when it was last modified and all the stuff that you have about a file now.
But what I'm saying is, we were talking about the idea of having an object to inode database somewhere else, and it's like keeping that somewhere else seems like it's going to probably run into problems.
Possibly, and it's kind of, to your point, where you draw the line between how much of this entire S3 thing is implemented on the ZFS side versus on the whatever the web interface to it is going to be. But yes, in most cases, I think it probably makes more sense to store most of the metadata as basically extended attributes and essays and so on to the object so that they're atomic with the object and in the same.
This is probably the point, Rob, where you tell us what you've played with so far before we go too far down that rabbit hole.
Okay, I'll make you cry later.
Why am I always the guy who does the stupid things?
We love you for it. Let her rip.
Because you actually are there and we ask you questions and you go, oh, sure.
No, you say, I tried that a few years ago.
You keep coming back. That's the problem.
Yeah, it's on me. My children ask me the same thing. Why are you still here? Just grumpy about having to do the dishes when we said we'd do the dishes. Well, I'm just doing the dishes. Shut up. Go to your room. I'm 21, Dad. No. Yeah. So yeah, we talked about this a little in the producer calls, and yeah, so we basically talked about the difference between objects and like buckets as their containers a little bit, and I don't know a lot of S3, so I might be repeating things that people already know or repeating them badly or whatever. But it seemed like the bucket is probably the equivalent of the data set, as in like container of objects. A bucket, at least from the API, the S3 API perspective, that's where you say, give me a list of objects, and it gives you a list of like, names and the ID or the key that you get them through the API. But it seems like cross-bucket operations are not really a thing. So based on that, it seems like the data set is the thing you create and give to people and say, put your stuff in here. So that might have been obvious to people, but I wondered about a per object kind of thing. The other thing that came up was, we were talking about versioning, and versioning seems to be that it's literally, you say, give me, my document.txt or whatever, and you get the latest one, and then you can kind of augment that and say, give me my document.txt at, version 3, and it'll go back in time, and you can also interrogate an object and say, how many versions do you have? So in that respect, they're kind of different objects, but at least the name has a current version, if you like. So that was sort of enough of a starting point, I figured. There are operations to get like a list of buckets, which is basically ZFS list, but it would mean that in an API sense, it becomes necessary for providing sort of DSL ops and data ops through the same API, inverted commas, which isn't necessarily an issue. It's not really a routing concept that we have as such. That's okay.
So maybe before you get
So I started.
further,
Sorry, go Alan.
Do you know what kind of requirements there are for listing the objects? So within one bucket, like would that be walking just the list of DMU object, like DMU next object over and over again and enumerating them, or are we maintaining like a ZAP?
I think we're maintaining a ZAP. I think it's basically a directory because they have names.
In one
they
big
have,
flat
like,
directory?
Human names.
Yeah, so there are, different APIs present different things, but S3, which is sort of the most standard API, will let you list everything that starts with a certain prefix, which is mostly used to do directory style things. And then it can also just do like an alphabetical list starting from a certain point without a prefix, which is used usually for like whole bucket iteration and like paginated list APIs and stuff like that, which are a big deal.
Yeah, I guess
of
the
course.
ZAP has the advantages for the pagination, but especially if this ends up looking like, if we have to maintain the ZAP anyway, what's the difference between this and a regular file system data set?
Yeah, so...
and, ZAP scales badly. Is there a different data structure?
So, yeah, it might be there's a different data structure. I'm not sure. I do have plans in the back of my head for some different kinds of ZAPs as well for different use, so maybe that's that. But yes, it could be a different data structure. I'm not sure. But at the very least, like a functional version would be ZAPs. Would at least do the job, just very terribly. But anyway, I started off just thinking, okay, well, this is probably, if this is a separate bucket data set type, so I wrote a little patch to, now I have bucket data sets, but they don't have any front end like zvol or zpl, so whatever, that was as far as I got, because it was only like last week or something. But part of the idea was, at least because we don't, the vague theory is like, this could be faster because we don't have to maintain support for a whole bunch of, you know, POSIX style things. We never have the notion of multiple things writing to the same object. You know, although there is a multi-part protocol for like staging a large object through multiple requests, that's off to the side. It's not actually a committed object. Once it's committed, it's there. All right, so, you know, we don't have to, and so we don't have to keep things like, you know, handle range locking or handle concurrent access. It's just reads. So there's a possible way that we can say, you know, we can remove some overheads. But that said, maybe the ZPL layer is kind of fine, because if we already have to have a user space component, maybe it works fine over a file system anyway, because like uncontended lock acquisitions are cheap. So maybe it is better to just have a whole S3 server in user space sitting on top of just the regular file system. But maybe we just want to, make directories faster or that sort of thing. Or maybe there's just a separate, like this idea of staging things, like or versioning. You could imagine versioning being a property that says how many versions of an object do I keep, and then they're like separately indexed. So it's sort of like a separate directory, but not. So maybe you get certain kind of interesting operational things that you put in dataset properties.
Well, yeah,
so
I
again,
see the interest of,
where do we?
Yeah, I see the value of a different data set type. It's just maybe that data set type isn't as different from a file system as we think, and even possibly there's the ability to mount an S3, a bucket data set as a ZPL data set to actually be able to go and look at it, but it's not, you have the better semantics where you know, like, we don't need to be able to support writing to an offset, right? Any change to an object is always write a whole new object.
Yeah, and that's how we actually use it right now, is we have an S3FS mount inside of a MinIO type of setup that's running on top of ZFS to actually get that presentation of a block view of it inside of an object, or inside of an object store.
But like, to Rob's point, you could have, you know, more file types or whatever, like node types, so that, you know, instead of having the file, you would actually have this thing that was basically like a directory, but it's a version file. So if you try to open it and read it, it'll work and it'll read the most recent version, but it's also a directory. If you CD into it, you can see all the previous versions of that object and then read and open them. So, you know, open file.txt slash file.txt.7 would give you the 7th older version of the object or whatever. But if you open the directory, instead of failing, hey, that's not a file, it would be magicked underneath.
If that directory is a UUID of blah, and then inside of that is blah 1, blah 2, blah infinite, and my metadata on what is blah, here's the versions, and here's how it was. That's, honestly, that's how Red does their cameras when they take shots. It's in a directory that has one name, and you look at all of them at once. They just have
Are
to
we
be
reinventing files 11 here?
Well, it's S3. That's the mechanism how S3 works. But being able to go through and expire in a logical manner, hey, anything that's older than this date, I only keep 7 versions of it. All of those things are S3 functions, but whatever makes the most sense from a ZFS standpoint in that bucket type, again, wide open. It's just what makes the most sense.
Yes. So I think it, to some degree, I think it's mostly, the what makes sense, I think, is just about how people would kind of want to use this. I think of the split between ZVols and file systems. ZVols are really just, they're a particular interface over a single object in a single data set. But it's like, why are they not, like on Linux, why are they not a loop device over a file on a file system? In fact, on Linux they're actually quicker because ZVol is kind of still a little janky there, working on it. But so it's that kind of thing, and I mean that's kind of a mostly legacy reason, but it's like, should this just be in the file system? But if there becomes operational things, which it would be much nicer for admins to go, yeah, I would rather just manage my S3 properties in the same place that I manage my dataset properties or whatever, my configuration, and it gets replicated around and whatever, then maybe that's a good reason to have it all built in.
Okay,
if there's a separate, if I can
Let him finish.
If you're talking about properties in S3, then you're going to have to start dealing with IAM.
Joseph, repeat that. Let him finish and then repeat it because you lost the end of him and the start of you. Go ahead.
You finish.
No, Rob, did you finish your thought?
When I say S3 properties, just on that, I mean configuration items related to the storage. I don't mean specifically what. Like I say, I have no idea of S3, so that's not an unreasonable way to interpret what I said. But yeah, that's not what I meant. But the last thing I was just going to say is, if we have to have a user space component anyway, because we don't want to do HTTP in the kernel, presumably, my gut feeling is we don't want to do HTTP in the kernel, but, we're just talking. Then maybe if we have to have a user space component anyway, then maybe that is just an off-the-shelf S3 server. Maybe we kind of bless one, maybe we write to their back-end interface. There was a good link that someone sent me a little while ago. So maybe we try to work with them, try to partner with someone to actually optimize ZFS. It's like, yeah, here are 2 or 3 special hooks that will make things go much quicker for you. And then the other option, which is a different conversation, is if we had a ZFS in user space, like a full-fat version, then it becomes far less onerous to put a HTTP server in it, and maybe we have the server for it is actually like a libc pool application, and you say, you've got those disks, and that's the S3 store, and you do the work there. Trade-offs, maybe you can't do file systems and zvols in the same box anymore, but I don't know. Maybe you don't want to because you only deal in one kind of storage. So those are other directions we could talk about, but I don't want to derail us too far. That's all I know. I got nothing else.
So what do you know?
Okay, so what I know is that managing IAM for...
What is IAM?
Nobody knows what it stands for, but
okay, sure.
It basically means access control. So managing IAM for S3 is a mess, and it's probably one of the easiest ones in Amazon. So the basic thing is you have groups and you have users. I think there's a different term for them. I think they're like, anyway, the point is they presumably don't map to your NSS users and groups, because if they did, then you'd need to have IAM keys or identifiers and authentication tokens to map to them. So you're not doing probably a one-to-one mapping like you would do with CIFS or with NFS. So at that point, what are we doing? Are we keeping it as metadata? What do we keep as the permission, as the files? Are we even presenting this as files to the rest of the system? Or is this just like magically on the disk and a blob and has no Unix VFS interface? Or do we want to have both and find some weird compromise? There are totally good reasons for both perspectives, but the lack of directories makes things exciting. Then, plus you've also got all sorts of weird, not in the initially released version of S3 stuff that is also managed as attributes and properties on these blobs. So do we present a BitTorrent interface to the data? I'm guessing no, but how much are we willing to accept of the S3 interface
and stub out, and how much are we just going to like shrug our shoulders and give a 4xx response?
I think it's if we go that each object is a directory.
Oh.
That then, versioning, metadata, ACLs, IAM type of activities, here are the acceptable keys that can access this. That's where that kind of matches how S3 operates. And then it's just exposing it if we need the block level view of it, which is the other piece of all this, is being able to mount it with S3FS to be able to do that type of handing it back over NFS or Samba or FTP even to do that, because there are some applications that, hey, I need to write to S3, but nobody wants to do an edit off an S3 object. They need to do it off a block object. So that's where we get into this mix of, hey, it's being written as an object, but it needs to be visible as a versioned block item or a block file. And that's where, honestly, that's the holy grail in my mind.
Repeat the Holy Grail, please, Stu.
That something can write an S3 object with whatever permissions that are necessary, that then can be accessed as a block object in the most efficient way possible.
Block.
Or sorry,
I think
sorry, not
the
a
most
block
important
file.
operation is basically send file.
Okay.
But doing it natively
sure,
without
yeah,
having to go through jump through three more hoops, if you can abstract that away from the end user. Because it could just be, hey, this is my path to the S3, which is an HTTP request, which is some other server that, hey, I'm writing to a ZFS bucket with these credentials and all that kind of stuff, and it populates it. And then I can mount it as NFS or Samba and operate on that with the permission set, the POSIX permission sets that way. That's the holy grail.
Yeah, I mean, that is the holy grail. User mapping is starting, just thinking about that is making me twitch, gosh.
No.
But
Have another drink.
But totally, like, I have my Mac able to do a backup to S3, and it's got checksums, so that way it can do basically an rsync algorithm, and so it's very efficient. It's not WebDAV, like it's not SMB. So it can be very efficient, but then I can browse it from any client and access it easily. That sounds delightful.
Like
One other thing is we have two vendors in the room who would probably very much like to build their S3 products on top of this. And I don't know how we are going to, so they have their own user group access control systems on top of their services, because this doesn't exist yet. So are we going to try and make this pluggable in a way that it can pull from another data store? Yeah. What does the management look like?
Right,
Is the other thing.
Yeah,
Now I'm gonna-
that's a whole nother mess. But again, if we're back in directories, the access is, hey, this is the S3 access level. Here are the POSIX access level in a separate file that can be read and managed and manipulated as it's being presented as block storage. Saying, hey, there's my cross-reference is based upon this, .auth file, for lack of a better term. These have my factals in it, and we're done. It's just another abstraction layer that needs to be sorted out, obviously, but I think it's achievable.
Like, is the goal of your kind of POSIX access to the S3 stuff the advantage that, you know, the POSIX read-write calls allow you to modify the middle of a file without having to re-upload the whole file like with S3, or?
It's not having to have duplicates out there, really, or to say, hey, you upload to S3, now I need to make a copy of it to be able to edit it, or to be able to.
Right.
So if we can operate on that object and still in the copy and write mode, you know, each new version of it is a new iteration on it that, hey, now I can pull that from S3, even though it's being done edited on blocks.
Right, so you're opening the directory rather than one of the versions.
Yep.
And then as you're writing to it, it makes a new version. What's the granularity of how often we make the new versions there? Is it every time you close the file that ends that version, or?
Don't know. That's, again, what makes sense. Is it every time it's saved? Does that do it, or is it, and then the retention and all of those other things again?
Yeah.
This is a dream. I fully admit it. But if we don't talk about our dreams here, they'll never get talked about.
Yep.
Andrew, what you got?
So one of the people on the YouTube watching crowd made the observation that the Joint Fellows had their Manta system. Did that just operate on the POSIX level, or did that take advantage of anything beneath it? And is there anything we can learn from that?
Which again, sorry?
The Joint guys had their S3 Manta, is what they called it.
So one of the differences between a normal file and an object is that a file is updatable and logically in place, whereas an object starts out as something ephemeral like a temp file and only gets its name when it's committed. So every time you want to write an object, you tell through the API, I want to write this, an object named this, and then you upload to it, and if the upload fails, the object gets garbage collected by the service.
And so I don't want to derail the conversation because people are mostly interested in S3 these days. But I think one of the other places where this sort of mechanism is useful is for databases with blobs, where the database is actually, the database is doing all the work of keeping track of the objects, and it really just wants to be able to say to the operating system, give me an object. Here's the identifier. The room got really quiet.
Let's say something like an IMAP server where you want to store the attachments as objects.
Oh, various folks. Are you familiar with Gary Grider's MarFS at Los Alamos? It was like near POSIX, and the idea was that you strip things down a bit for performance. For what it's worth, there it is.
So what S3 does not offer is it doesn't offer a hierarchical organization. So you cannot rename a directory in S6. You have to do these kinds of operations at the object scale instead of the directory. Directories are just a convention.
Other dream wish list items, yes, please.
Yeah, I want to check with Rob or Alan. Is there any thoughts on the layout of the inside the data set for object? Because the standard directory level would introduce contention and with the standard like AWS object, the objects are spread across the server. It's not on a single system or JBoard you're doing. So any thoughts on that internal layout? How?
Well, like for the data set itself, I mentioned earlier, I'm wondering if we actually need a zap or not, like to make a directory, or if we literally just, step through the list of objects in the DMU and for each object just retrieve its name as, an attribute from the file. And that has some advantages, but, doesn't allow things that Paul pointed out, like listing all the files that start with a certain prefix, short of going through every object and only returning the ones that have a prefix versus, maybe with the zap it's a little easier to kind of just iterate through the list of file names and figure out which ones match a prefix.
And then you need a higher performance data structure.
Yeah, and then we probably need a higher performance data structure than the zap if it's going to have, hundreds of thousands of objects in it. The zap works okay for directories, especially if there are less than 2,000 files in each directory, but if you're doing the entire bucket as one flat namespace, that gets a lot more difficult.
Yeah, right.
Yeah, if you need to be able to do like queries like that, like say, all the objects that begin with, these 5 characters or whatever, you could imagine building an index of some kind. So like basically a search index. They might be individually zaps, but the interface would be different, I guess. I'd love to have query
I guess if it's a
stuff
prefix,
like
I
that
wonder
for
about
directories would be awesome.
A zap that's sorted by the value instead of the key, but I don't know how practical that is.
So I can just say for S3 compatibility, list object is horrible. Like
I think there's a reason there's a list object
v2. You don't get
v2.
enough of them. You cannot get all of the objects in a particularly large bucket. You're probably missing some, and it does not have the consistency model that say actually the objects themselves have. So you get write and immediate read after read will be consistent is in S3. They didn't used to be, but now it is. But list is not like that. And so trying to do, say, cleanup operations is a bear. You have a hard time making something as awful as what S3 guarantees.
Does allow you to list everything with a certain name prefix, and it allows you to read everything starting at a certain name for pagination.
But it also may go back to as long, and kind of our theme is where does it make sense for ZFS to stop? If we say that ZFS stops at being able to store multiple objects with 3 or 4 extra files with each one as a directory, for lack of a better term, is that enough for somebody else to come through and make the front-end interface that is S3 compatible to handle all the rest of the cruft? Which I am more than happy to say that is a great stopping point for ZFS, providing that plumbing, and then let something else do that. It's a step forward, and that's all I can hope for at this point.
In directory, you don't get versioning then, right?
No, you still get versioning because each object is a version that's inside that directory.
Okay, yeah. Okay, I was thinking like something like snapshot. If you snapshot, it gets automatic versioning.
Right, and again, it's one of those until we figure out what the right architecture is do it. Okay, now what does snapshotting mean in that context? What does, hey, this is an S3 snapshot, I only want the last 3 or last 17 or 487 objects in that snapshot based upon the retention policy of that bucket or of that single object that has multiple objects.
Right. Yep.
Yes, it's confusing.
So I was going to say, the way I'd probably approach this, because there's so much we don't know about what we could provide, would be to start with something like an off-the-shelf object store thing, I think Stu linked me to a thing called Versity, which has this sort of pluggable API for different kinds of storage backends. And I'd probably write or start with like the POSIX version of that and play with it and then read the code and look at, oh, this thing is jumping through a lot of hoops to manage this particular kind of concept or object or type in the POSIX layer. ZFS already kind of knows that internally. Maybe that's something we could give it. And then, you know, try and thread that through. And then, you know, I feel like there's probably a point where you start to find where the concepts are. You start to find a bunch of shapes where it's like, yeah, this is where we could help this server. This is where we try. I mean, if it's in the data path, then like, okay, we just get on with it. But sort of what it's smelling a little like to me. I don't know.
Yeah.
Because otherwise we're just going to go, oh, well, where do we put all of these things? And then we still don't know what's in our user space blob. So I don't know. That's probably how I'd approach it.
So if I can make a request of the developers, who mostly aren't here yet, one of the sort of no regrets investments, I think, from all of this would be actually better, faster, more efficient data structures for directories. Because I already have an issue where my users are creating directories with single directories with hundreds of millions of files. And that's, I mean, like even rm-r is difficult on a directory with 100 million files in it. If only.
That reminds me of my trick with the objdr in FreeBSD when you're compiling. I take a snapshot of it when it's empty, because it's faster to ZFS rollback empty than to ch flags, take all the immutable bits off, and rm all the files, than it is just instantly roll back to a version of the data set that was empty. But yeah, a scalable directory thing is definitely interesting. Like, we did a bit of work at Clara to extend how big a microzap could be, so that you can get up to like 16,000 files in a directory before you go to indirect fatzap. But you know, that helps with the latency of creating new files and RM and so on, but only to, you know, a few orders of magnitude less than what you're looking at. And with the level of indirection there, I'm guessing you would see what we saw was this kind of step function where the amount of time it takes to do something to a file keeps stepping up every time you add another level of indirection. And at 100 million files, that zap's got a lot of indirection.
Is the reason for that slowdown just like we have to open all the indirect blocks and we don't have any of them in the cache? Or what is the, because like, it seems like if we could have ZIL entries.
The slowdown was writing the new versions of them after we added a file.
But couldn't we just do that in the ZIL or something? Like if we put it in the ZIL, we could just wait until sync time and then it's not blocking the critical path.
But in this case, the ZIL was also on hard drives, right?
Sure, but the ZIL entry for like we are adding a file would be a constant size.
Right,
it wouldn't
rather
be
than
dependent
the
on the size.
The content of the indirect blocks, yeah.
Right.
Yeah.
I mean, I don't know. There could be obstructions to that, but that, I mean, seems like something to investigate.
Yeah.
So, assuming you spend the time to build what's in your head right now, what do you get out of it? Like, I don't feel like you've described a thing that gives Stu his heavenly final destination, and I am not sure how we could use it. I mean, let's just assume for a moment that we handle authorization entirely as some metadata stapled onto the object, and it's the HTTP server's job to go wire that up to some authorization database. Sounds great. You've got, how is this better than files? I think is the real question. Like, you already have files that do a lot of this. Why is this better?
Yeah, I think that was Rob's concern, is we speculate that this would be faster and more performant than the POSIX interface by eliminating a bunch of complexity, knowing the fact that you're only going to ever overwrite a whole object, not modify the middle of it, and a bunch of things like that. But a lot of that is theoretical, and yeah, that's one of the risks here is we built it all and it turns out it's not any faster than having just run it against a POSIX file system underneath.
Which is functional.
Mm-hmm. Which does work. It's just, would this make object storage faster and easier to manage and maybe less complex in the applications case, or just less fiddly with the semantics of fsync and so on, because we know that we're never going to modify the middle of a file. It's always going to be, we created this whole file as an atomic operation.
So let me try and answer my question, because I'm trying to imagine, I'm trying to ask it better in my head. And I think the formal version is, what is the difference between me building a Minio clone with this versus a Minio clone against files on ZFS?
The rug pull, the licensing change.
Well, right.
No, but he's saying, he's saying writing his own. It's just,
I mean,
what are the advantages
it's going to be
of building
IFC,
it
so
on
you're
top?
fine. So, like, the advantage of me using POSIX files is, I can give up on use ZFS folks and move to BTRFS, but that, okay.
You'll be taken outside and beaten.
Right, correct, exactly. I can quickly get myself beaten. But if I do either of them, I get replication. If I do either of them, I get the reliability and the tools that we have.
So my answer is, it's the same set of tools and the same process to do replication, to do snapshotting, to do moving data around the world the same way, regardless of how it's coming into it. Making an object look like a block to be able to act on it like a block is overhead. And if we can avoid that at the lowest possible level, which is at the data set level or bucket level, which is the same in this scenario, then we can use the exact same tools. We can use Zelta to move shit around. And those type of things that, as a administrator of thousands of systems, simplifies life versus having to go through an interim step before being able to simplify my life.
I think the other big one is, instead of having to have your application translate a put into open, or well, maybe do something to version it, open, write, fsync, close, you would have the equivalent of like, create an object, here it is, put as an atomic operation, instead of open, write, fsync, close. And, at millions of objects a second or something, that one syscall instead of 4 could actually make a substantial difference.
And maybe this is to the appliance vendors of the world, but if the customer wants a block device, you give them a ZVol and tell them a few things and don't hear from them. If they want S3 storage, you just add it and give it to them. And yes, we're doing it with Minio until the change, and then we're using, what is it, GarageFS until maybe they'll change license, and then there's going to be SewageFS or something, and then they'll change, and it's like seaweed and sewage. Oh yes, that's it. So it's like that's a motivator, but then full circle to, well, the DMU is an object store, and just like the libzfs itself, what can that look like to interface with it? How do we cut out the middle person? How do we just point blank efficiently speak to this great plumbing? Because the plumbing I trust more than many of the kernels it runs on. It's like, good work, gang. Rain's picking back up. Let's go get a really wet picture. Anyway, so at a high level, this could have been phrased as S3 best practices on OpenZFS. Fine, but let's think big. And Stu, thank you for thinking big. Thank you, Joseph, for spelling out what those questions are and occasionally answering them. That's appreciated. And Rob made a very good point by chat, so thank you for that. So Looking at the Luster example, were there any other science projects over the last 20, 10 or what, 15 years of just a lower level interaction with ZFS? Or we just have these one-off quirks that serve some people well or one company well, and we don't have much to share?
Not ZFS specific and not something I've done, but Plan 9 had the content addressable file system where you open a file by like its SHA-256 hash rather than its name. And that could be interesting, but I don't have a use case for that.
I mean, there's actually like probably a dozen distributed file systems that are built on that model.
Oh, and granted, the AWS folks will arrive tomorrow, most likely. Hopefully, there are no interruptions to that. But do we have a sense of what they're up to relating to just the shortest path between OpenZFS and S3 services to the wilds?
Like the AWS people that are coming and do the FSX, which is basically we run ZFS on a ARM AC2 instance and give you NFS access to it.
Give you what access to it?
NFS.
NFS, I see. Okay, cool.
And so it's just,
okay.
they're just providing, you have your choice of a Windows file server, NetApp, I think Luster or ZFS, and ZFS has good compression and a couple of advantages that make it really interesting to people to be cheaper than their Elastic NFS service.
Except no Samba.
Yeah.
But no Samba.
Well, and you can't speak to the ZFS except for via the .zfs directory.
Joseph, do we have you to thank for the Saga comment?
Yeah.
Okay. Well, would you like to address that?
Not at all. There was somebody mentioned, I don't know about cross-bucket operations, and I just wanted to say that there's a solution and it sucks, but everyone agrees with how to do it. Sorry. I was looking at Garage FS, and it looks like they're using a database called Fjol, which is a log-structured embeddable key-value storage engine, which, hey, that is actually what you just described. So, cool.
And I was thinking seaweed, but all those catchy names get a little confused in my head. Well, Stu, are you optimistic about getting your pony, or, yeah?
I can't write it. I can only ask and help guide.
You left out fund.
Whatever is needed, I'm happy to help or test, but ultimately, if it's going against a standard, if it's standard adjacent, that may be good enough.
Yes, Daniel.
For the production users that are trying to follow best practices for this today rather than next year, has anybody raced the different S3 implementations? So I heard that somebody was testing with Seaweed and Garage and found Garage a little lacking in the performance department at scale.
I've done 4 personally.
Oh, do tell.
Yeah, Veracity, MinIO, Seaweed, and it wasn't Garage, it was something else. But Veracity was not as complete as I needed, but it is functional for getting content to our storage.
And what was the name of that one?
Veracity.
Oh, the one mentioned earlier?
That's the one I sent you.
Okay, thank you.
And the one that I sent to Rob. And it was all 11 days ago, so, I mean, what a slacker, I'm telling you. Doesn't have a prototype yet. MinIO is fully functional. Licensing, they're messing around with again. And it's performant, but again, milliseconds here add up at scale. I wasn't really happy with Seaweed, but I may have not deployed it right. So
it's a little more complicated, right?
I didn't spend a lot of time on it either. Does it work?
Yeah, I think I played with it for a minute, and then I needed something in production and used MinIO.
Yeah. So, as these self-hosted versions go, MinIO is functional and works. Could it be more efficient? Absolutely. Is it something that, you know, we just say, hey, Manio, what do you need from ZFS to make this more performant? That may be a conversation if we go there, or some other yet to be discovered GitHub project that I haven't seen yet.
With a clever name.
Yep, with a clever
Seaweed
name.
was, what was your summary of seaweed here for the completeness?
I didn't have it didn't leave any memory. So it was just, it wasn't good enough to make me move.
I've heard it's zippy. That's all I know.
Zippy, okay.
Well, if Daniel says it's zippy.
Well, I've heard it's zippy.
It's not Delta E, but it's zippy.
Right.
If it was Delta E, then we'd all be running it right now and we wouldn't have this conversation.
Yeah, and see, it might be as simple as, like, you know, I see, you know, performance is good, milliseconds add up, could be more efficient, just reading the notes. I'm like, okay, that could be a, you know, just a performance analysis engagement and maybe some tuning, or maybe we identify one hotspot and we tidy that up and suddenly it's perfect. So, like, it could actually be a very small amount of work comparatively.
Yeah, and with, you know, the unfortunately, the one we missed yesterday with Ava not being available, you know, that could feed directly to this as well. It's like, you know what, we can tune ZFS to do this a little bit more efficient and everybody wins. It may not be worth the effort. Again, I am a realist, so if it's not worth the effort, I get it. But if it is, and it could be fantastic, why not?
Go ahead, Garrett.
You know, I was just going to say, like, a lot of this really feels like it needs someone to make an investment in, you know, hours to actually figure out what are the actual issues that prevent you from getting the performance that you want, and possibly that also means a much bigger investment in hours in prototyping something that could fix those issues to see whether it's actually going to be worthwhile to do on a general basis rather than...
And hardware and everything else, absolutely. And those are things that, if it makes sense.
We've got a hackathon coming up with great prizes, such that if someone wants to take a few hours to explore some of those bottlenecks, I brought an Epic server that I'll try to wire up tonight and let you do some NVMe storage. And if you need a client to access it, I can bring another machine, but I just started there, and we're dodging raindrops with it. Any final thoughts? Rob, do you want to just give us some words of wisdom from down under? What would Rob Norris do?
I don't know if Down Under has a lot of wisdom any more than the rest of the world. Yeah, nah.
But Michael loves
I got
saying
nothing. Just figure out what we want first. Yeah, profile the existing thing.
I think that's what we're trying to achieve, is to figure out what we want.
Yeah.
Thank you, everyone, for helping us figure out what we want.
I feel like this.
Speaking of which,
Recording stopped.
figure out. Speaking of want, we have some fantastic leftovers, and Stu, if we can get some in the oven, and maybe, I don't know if the grill is helpful to heat up something else in parallel. They're already in the oven? Can you describe for our listeners and audience?
The Thai food from yesterday.
Thai food is in the oven. Go ahead.
Thai food from yesterday and the artichoke dip are in the oven. If you want warm steak, I can make that happen, but cold steak is good too. My preference, actually.
It ages well.
Yes. So, other than that, the beans are warm from last night as well. I can reheat actually, no, we don't have any meat chunks left because, no, I've got some smoked pork that we can still add if we want. That'll be about 20 minutes. So.
I don't know if you caught
If you guys want to stay, great. If not,
Oh.
won't do any work.
I mentioned SNIA ever so briefly. I've spoken at the STC a few times, and that's where I met Mohammed with the Seagate office of the CTO. And he asked if it's worth dropping by tonight, and I said, absolutely. So he will be joining us, and he's full of wisdom. Great guy. So if you want to meet Mohammed, he'll be here hopefully shortly, because it can't be, what is it, traffic time, or it's pre-traffic? Oh, it's a little early. So he should be here soon. So anyway, I hope this is useful and enjoyable. Silence. Jeez. Ouch. Okay, well, no, kidding. I welcome your feedback. This is your event, not mine. You're loving it, Rob? Did I hear
Yeah.
that? Oh, cool.
Yeah,
Sweet.
I get to talk to people from my quiet little room on the other side of the world. That basically never happens. This is great.
What do you actually see right now? The feed, or did we get the webcam up to see the group, or what could
Right
make
at
this
this
better
moment,
for
I can
remote
see-
participation except the latency?
Yeah, right now I can see the people in the room.
Ooh, thank you, Patrick.
So from the front left of the room. Yep, there's Alan right in the middle with his
That guy.
wave. So.
Oh, cool.
Yep, and now I can see you up there. So.
Oh, okay.
It's been alternating between everyone and the slides, which is good.
That was
not
kind of the
slides,
point.
document, which is good because I don't have that on screen.
And the document
That'd be
sometimes
great.
it sits there not changing. Is there any way we can improve the remote participation?
This is actually really good. I can hear very well. Everyone who speaks up. So I don't know what you've done. Have you mic'd everyone? Or what?
Archie, get your butt up here. Patrick, come on
Push
up.
to
Just
talk
get in front of a
microphones at the
camera. The day before we launched, they tuned the audio in the room. They interacted like crazy with all these nifty gadgets into the Skype interface, or the Zoom interface. And apparently it shows, but not
Well,
shows. It
you
sounds.
Have, you have done a stellar job. I can hear the whole room. It's brilliant. Thank you. Really
You're
appreciate
welcome. Did you buy the damn ticket, or will your boss buy you one so you can get a T-shirt sent to you like last year? Anyone?
Well, I bought a ticket.
Oh,
I'll
you did?
check with
Okay.
my boss if he'll cover that for me.
Okay, cool. That's between you two. That's between you two.
No, it's fine.
And I'll replenish you on stickers for that continent. That's kind of important. We have this like distribution network, be it here and there. Well, everyone, the sun is still up, but there is nothing short of your jet lag and your tolerance for other developers and Thai food and steak driving you out of here. So thank you from my heart. Thank you. This is me running just on instinct, having attended many events around the world and thinking we don't need more hotel food or trade show floor, which occasionally has great swag and it's super computing. They'd give away like full iPad tablets, which is great, and now they're down to like the pen. And it's like, oh, okay. Thank you. If you're lucky, is the comment. It's like, yeah, okay. So the good old days are gone.
The good old days where you could go in with a suitcase and come back with 12 polos that you didn't have to.
Okay, I have a true story about that. So one of the last open source events, not OSCON, but the last gasp at the Moscone Center took place. They had the .org ghetto in back. The name will come to me. But this woman came by with her suitcase, and she's like, I do all my Christmas shopping here. It's like, oh, I don't think vendors want to hear that when they plowed that money into those shirts, etc. During lunch, we left Zoom on, and is there any objection to just, Rob, I know it's early for you, geez, you're welcome to stick around. We could even bring a camera maybe closer or something just so that we can kind of
It's all right. Look, it's 11
work
a.m.,
to do.
but it's kind. I know you should all go and have chats and food. It's hard to. It's hard. It is hard to include that. That's part of
that part. Yes.
The day. So that's okay. If anyone wanted to talk to me, like you can ping me online. I can jump back on Zoom. I can do whatever. But I think I'm.
You've got DoorDash, right, or something? I don't know.
Yeah, I'm going to get something to eat and then probably watch the F1 race. No spoilies, please.
Or the ballet, as it turns out.
Rob, I did want to ask you a couple of things about
Or is it
testing,
figure skating?
so if you
Yeah, absolutely.
hang around for a minute.
Yeah, I can hang
I'm
around.
not sure
yeah.
I need to be projected throughout the
Maybe
entire room
just
so everyone
leave
can
one
hear my
microphone
questions.
on so that you can have a Ask the Remote People station.
Oh, maybe move the...
Am I so
Purely
quiet?
with the mic or something or whatever? Okay. Use a handheld. Hook us up with a handheld. Oh, chair, nice. Oh, but the camera's then the back of their head? Or?
I mean, I'm more than happy to talk to a disembodied voice. It's okay.
We could kick in the webcam. So, AV team, could you AVify? Thank you, everybody.
Enjoy your dinner, everyone.